What's up, everybody? Welcome back to the continued ALEKS challenge. We are now into part 8. It's funny, when I first started this challenge, I thought about doing this entire ALEKS pie in one sitting in about 12 or 15 hours. I think I've definitely already surpassed that 15-hour point, and I'm not even close to halfway through. I'm about 38% way through, so it's a lot of work. And I think the cool thing about doing this challenge is that I have some perspective for my students who have to also go through this program. It's a lot for pre-algebra. And by the way, for those of you who are not familiar with ALEKS, ALEKS is an online math curriculum program, which is really cool. We use it at my school to teach math from 3rd grade and upwards. And it's got this great math curriculum that's self-paced. It's mastery based, so it's not about percentages or test scores. It's all about once you understand the topic and can demonstrate that, you move forward. And it constantly checks your understanding based on a mastery level, which is determined on these things called knowledge checks. So anyways, you go through the topics, you answer a certain number in a row correctly, and then boom, you move on. So anyways, we're going through the pre-algebra pie, and we're continuing on today through the pre-algebra pie and 38%, and we're going to say continue my path. I'm going to see how long we can go. There's no school today for me, so I'm home all day. I'm going to try my best. I've got some coffee and I've got some food next to me if I need to eat and take a break, but I'm going to try and go for as long as I can here. I don't know how long that will be. Will it be 1 hour, 2 hours, 3 hours, 4 hours? I'm going to do my best and see exactly how long we can go and how many topics we can knock out. Without further ado, let's do it. Oh, and let me do a quick sound check and make sure we're working.
See exactly.
Yeah. All right. Let's jump into it. All right. 35 over 20, right as a percentage. And this topic is denominator 25 or 50. So the idea is, remember, percentage is percent, per 100. That's all it is. So when we have these nice denominators, like, let me zoom in a little bit here. When we have these nice percentage fractions that are over factors of 100, we can think, well, since percent is per 100, if we can just multiply this denominator and get it up to 100, it's going to be a lot easier. So I'm going to multiply the bottom by 5, since that'll take me to 100. And then on top, we always have to do the same thing. We always have to keep it balanced. So 5 times 35 is 175, I believe. And then the cool thing is, if we're trying to convert it to a percentage, once we have it over 100, it's literally 175 per 100, or 175%. And that's our answer. All right, next question. Same deal, 40 over 25. So what we got to do is we got to get that denominator up to 100. So I'm going to multiply the top and bottom by 4. And we get 160 over 100, which means our answer is 160%. All right, and last but not least, we've got 19 over 50. How do we get 50 up to 100? We multiply it by 2, multiply the top by 2, and we get 38 over 100, which means the percentage is 38%. All right. One and done. Next topic. All right. A boat is carrying containers that weigh, so this is making a table and plotting points given a unit rate. A boat is carrying containers that weigh 3,000 pounds each. Use this information to fill in the table, then plot the ordered pairs given by the table. So number of containers. So each container weighs 3,000 pounds. So 2 containers weighs 2 times 3,000, which is 6,000. 6 containers weighs 6 times 3,000, which is 18,000. And then 8 of these, again, it's 8 times 3,000. No calculator, but we can do these mentally. It's just like 8 times 3, which is 24. But then we got to add on the 3 zeros. And then we want to plot this out. So check it out. We've got number of containers here, weight up here. So when there's 2 containers, we said we calculate a value of 6,000, right? I'm just plotting that point. This is an ordered pair. Then we have 6, 18,000. 6, 18,000. and then 824,000. 824,000. And that's it. Let's check it, and we are done. All right, let's move on to the next one. Frank earns $10 for each hour that he works. So 3 hours, again, this is a multiplier. 3 hours times 10 is $30. 5 hours times 10 is $50. 6 hours times 10 is $60. And let's plot these out. So at 3 hours, he's making, $30. At 5 hours, he's making $50. And at 6 hours, he's making, $60. And I think those are the 3 points. 330, 550, 660. All right, last problem. We've got a large museum. There are 60 people in each tour group. So one tour group has 60, 2 tour groups has 120. 4 tour groups, we do 4 times 60, which is 240. And 9 times 60, which is 9 times 6, which is 54. And you add 1 0. And those are your data points. So 2, I'll write them down. 2, 4, and 9, 120, 240, and 540. And we've got, 2, 120, 4, 240, and 9, 540. All right, cool. You can see kind of all forms align, so we know that's correct. Yeah, 2 topics done. Let's keep going. Mode, mean, median, and mode, all measures of central tendency. Mode sounds like most, therefore we're trying to find the value that occurs the most frequently or most times. So find the modes of the data. Now there can be multiple modes. So what do I mean? I can see that there's a lot of 2's. So I'm going to first see the number of 2's that I can count. 1, 2, 3, and 4 2's. Okay. Let's see the number of 3's we can count. 1, 2, 3, 4. Let's see the number of 4's. I think there's also 0. So number of 4's, we've got 1, 2. And number of 0's, we've got 1, 2. All right, so I think that's all we've got here. Now, what is the number that occurs the most frequently? Well, it's 2's and 3's because they both occur 4 times. These guys only occur twice. This is 0 times. Sorry, 0 is not 0. That's a mistake. 0 is twice. I don't know why I put 0 there. So these guys are less. So this is our mode. So the mode in this case is 2, 3. Now they all occur the same amount of times. We wouldn't say there's every one is a mode. We just say there's no modes. But in this case, we've got 2 modes. Let me just make sure again. 1, 2, 3, 4, and then 1, 2, 3, 4. Yeah, and that's it. Same thing again. Let's go. We've got 16, 17, 18, 19, 20. 16, 17, 18, 19, 20. We've got 1 16, 2 16s. We've got 1 17. We've got 1 18, 2 18s, 2 18s. We've got 1, 2, 3, 4 19s. And then we got 1, 2, 3 20s. And by the way, this all adds up to 12 elementary school classes. This should add up to 12. Let's make sure it does. 2, 3, 5, 9, and 12. It does. There's only one value that occurs the most amount of times, which is 19. So we only have one mode in this case, 19. All right, this one we got 1, 2, 3, and 4. Let's count them up. So ones we have 1, 2. 2 we have 1, 2, 3, 4. Wait, 1, 2, 3, 4. 3 we have 1. And 4 we have 1, 2, 3, 4. Here are our 2 modes. We have this one occurring 4 times and that one occurring 4 times. Therefore, we have 2 modes. We have a mode at 2 and we have a mode at 4. All right, continue. Finding a percentage of a whole number. It says no calculator. So we've got 70% of 53. This is a two-step problem. So first of all, it's important to know that when we have a percentage of something, this of is the same as multiplication, or dot for multiplication. So we're really doing 70% times 53, but we never use the percentage in a multiplication problem. We first convert it to its decimal equivalent. Don't forget, down for the party. To go from a percentage to a decimal, we move the decimal spot twice to the left. So we go once, twice. This becomes 0.7. 0.70, or we can say 0.7. Zeros to the right after a decimal point are irrelevant. So we do 0.7 times 53. So let's do it up here. We've got 7 times 3 is 21. Carry the 2. 7 times 5 is 35 plus 2 is 37. Where do we place the decimal? We have one digit to the right of the decimal, so we move the decimal one spot to the left, and our answer is 37.1. All right, next one. Now we're going to go 50% of 81. So again, 50% times 81, but first convert this to the decimal equivalent. We move it once, twice. It's 0.5 times 81. 5 times 1 is 5. 5 times 8 is 40. One spot to decimal, one number's to the right of the decimal, so we do the same thing. One number to the right of the decimal, and it's 40.5. Last but not least, 80% times 68, but we move the decimal once, twice. It becomes 0.8 times 68. Multiply 8 times 8 is 64. Carry the 6. 8 times 6 is 48 plus 6 is 54. Oh, whoops. And then we move the decimal spot once to the left because we have one number to the right of the decimal. So boom, moves it once over. And it's 54.4. Okay, next. Introduction to using substitution to solve a linear equation. Oh, cool. This is a system of equations. Very important stuff. X plus y equals 6, x equals 2. So we have two equations. We have x equals 2 and x plus y equals 6. Now, we already know that x equals 2. We want to solve for y. How do we do that? Well, we know that since x equals 2 down here, I can just go ahead and plug it in for this x up here. And so now we're substituting that 2 in, so it becomes 2 plus y equals 6. Now, how do I solve for y? Well, I've got to isolate y. Since 2 is adding to y, I'll subtract 2 from both sides, doing the inverse operation, and we get y equals 4. And if we come back to this equation, it makes sense. If x is 2, 2 plus 4 equals 6. It's correct. All right, next question. Y equals x minus 12. Y equals 14. Okay, so substitute in to solve for x. Since y equals 14, I'm going to plug it in up here for y. We've got 14 equals x minus 12. Isolate x, so now we're subtracting 12 from x. Let's add 12 to both sides. And I've got x equals 26. Last one, y equals 4x, y equals 24. Same deal, I know that y equals 24. Let's plug it in up here to solve for x. 24 equals 4x. Now I need to solve for x. Since 4 is multiplying the x, I'm going to do the opposite to isolate x. I'm going to divide both sides by 4, and I've got x equals 6. All right, cool. Next question. Word problem involving the area of a rectangle problem type 2. Let's start. Dale wants to wallpaper the back wall of his bedroom. The wall is in the shape of a rectangle. It is the length of 13 feet and its width is 9 feet. So I'm going to draw it out right now. By 9. Suppose wallpaper costs $7 per each square foot. How much will the wallpaper cost for the wall? And we can use a calculator if we want. So first of all, we need to calculate the square feet. So how do we do that? We do width times length. So 9 times 13, which is 117. So it's 117 square feet. Now we know that for each square foot it's $7. So since there's 117 of them, we just multiply this whole number by 7. We can use the calculator if we want, but I'll do it for fun. 9, 7, 11, carry the 1 and 8. So it should be $819. All right, next one. Kira wants to plant grass in her backyard. Her backyard is in the shape of a rectangle. Its length is 31 by 24. Draw a smaller one this time. 31 by 24. Suppose each pack of seeds covers 12 square feet. How many packs of seeds will she need to cover the backyard? So what's happening is, first we need to figure out the total area, and then each pack covers 12 square feet. 12 square feet. 12 square feet, so on and so forth. So first let's calculate the total area, which is 24 times 31. That's 4, 12, 0, 2, 6. So it's 784 square feet. And then we need to determine how many times, now like how many 12s can we divide up 784 into, meaning it's a division problem. 784 divided by 12. So that's 6. Oh, is this not exact? 6 times 12 is 72. And then it's 560 minus 40.3. 65.3. Oh, wait, I must have made a mistake. Let's see. 4, 124, 2 and 6, 4, 8, 7. Yeah, let's see. Let's double check on the calculator. Did it say to, unless it said to round? Because otherwise the answer would be 66 if we have to round. But let me see, make sure I didn't do that incorrectly. 31 times 24 equals 744. 412. Oh yeah, I added that wrong. That's what happened. So it's 744. 2 plus 2 is 4, not 8. And then that's 24, and then it's 62. Right? So we basically, where I made the mistake was here. So now we bring down a 2 instead of a 6, and then it's 24, and 24 goes in twice. And then we're done. So 62 packs. All right, cool. And then last one. Michael wants to paint the ceiling of his restaurant. The ceiling is in the shape of a square. Its side lengths are 48 feet. So we got 48 by 48. Suppose each can of paint will cover 192 square feet. Each can covers 192. And etc. How many cans will he need to paint the ceiling? So again, we got to figure out what type of problem this is. First, calculate the square feet, which is 48 times 48. Which equals 2,304. And then what do? We need to divide by 192, because now we're seeing how many of these cans of paint, which cover 192, do we need? And if we do that, we get 12. So 12 cans. All right, cool. Let's keep going. Converting a decimal to a proper fraction in the simplest form, basic. 0.25. Okay, now, first what we do is we got to figure out the place value of that last digit, right? Here's tenths, this is hundredths, thousandths, and this is 10,000ths. All right. So since this is 0.25, it ends in the hundredth spot, which means we put this number, forget the decimal, take away the decimal and put it over 100. And that's it in fraction form. But now we can reduce it. We can divide the top and bottom by 25. and we get 1 over 4. And that's it. That's how we put it in simplest form. Okay, next. We've got 0.6. So 0.6 is in the 10th spot as the last digit. So that means we put the 6 over 10. And then to reduce it, what can we divide the top and bottom by? 2. And we get 3 over 5. Whoops. All right, next we got 0.1 as a fraction. Remember, this is 0.1. It's in the 10th spot, so we put 1 over 10. And we can't reduce it. That's it. That is already in simplest form, and we're done. Signed decimal addition and subtraction. So first we're doing 6.64 minus 13.874. Remember, when we're talking about combining a positive and negative, which is what we're doing here, it's essentially a subtraction problem, but we look at where the larger number is, larger in terms of absolute value, and that's right here. So all we got to know is it's the larger number minus the smaller number. So first things first, let's set it up that way. I'm going to say 13.874. Don't worry about signs just yet. We're going to set it up like this. I'm going to add a 0 to balance it out. And guess what? It's all about that dot. Got to line up that dot. Now we'd subtract down just like any other number. 4 minus 0 is 4. 7 minus 4 is 3. Minus 6 is 2. Here's the dot. Can't do 3 minus 6. It's 13 minus 6, which is 7. But then we need to figure out, is this a positive or negative? Well, which one was more dominant? The negative was more dominant. This was a minus. This minus means that 13.874 is negative. The negative wins the battle. So this final answer is negative. So we get negative 7.234. Okay, now let's look at this other number. We've got 7.28 plus negative 3.65. A plus negative is the same thing as subtract. That's it, right? They're different signs, so it's a subtraction problem. But in this case, the positive is the bigger one anyways. So it's a straight up standard subtraction problem, but with decimals. So the key is line up that dot and then subtract down. 8 minus 5 is 3. Can't do 2 minus 6. We borrow just like any other subtraction problem. 12 minus 6 is 6. And then 6 minus 3 is 3. So 3.63 positive. Next question, negative 2.34, negative 6.52. Guess what? They're both negative. Same team means this is an addition problem. But since they're both negative, we know our final answer is also going to be negative. It's not like multiplication or division where they cancel each other out. This is more like it's negative 2 degrees, and then it drops another 3 degrees. It goes to negative 5. So it's negative movement with negative movement goes even farther into the negative. So let's add these two together, and we get 6, 8, 8. But it's negative because those are both negative. So negative 8.86. And then this is a negative and a positive. So this is a subtraction problem. I'm going to set it up as that larger number, 45.3 minus 2.8. And this is 4, 5, 2, and 4. And since the positive is dominant, this final answer is positive. 42.5. All right, last one. Negative and a negative. Two negatives. Remember, I said that minus is just like a plus negative. So these are two negatives being combined. So we're going to add those two together like so. See how I'm lining up that dot? I'll add a 0 to fill in the missing spot. You don't need to, but it helps. 1, 12, 12, bring down that dot, and 7. So this is, and by the way, since they're both negative and combining, it's a negative. So negative 7.221. And then what about this guy? We've got 13.32 combined with a negative. So different teams is a subtraction problem, but I'm not going to put this on the bottom. I'm going to put that larger number, absolute value number, on the top. And do a subtraction problem. Different teams is subtraction. 6 minus 0 is 6. That's 7, 2, 5, and 1. Now, is this going to be a negative or positive? Well, that negative number dominated. It's a larger absolute value, so this final answer is negative. It's negative 15.276. All right, sweet. We're going to keep it up. Just going to run to the restroom super quickly. All right, I'm back. Got a swig of water. We're gonna keep going. Okay. Now we are finding the area of a right triangle. All right, sweet. Area of a right triangle on a grid. What's the formula for the area of a right triangle? It's 1/2 base times height. Why does that make sense? Because think about it. If this were if we filled this out, right? It would be a rectangle. It would be one giant rectangle. And look at this. If I were to show you something here, if we had this completed as a rectangle, right? The formula would be base times height. But then they've cut it in half. Now they just want this triangle portion, which is exactly half of that rectangle, which is why we still do base times height, right? Then we take 1/2 of it. So now let's apply that here. What's the square units? Well, let's count this base, which is 1, 2, 3, 4, 5, 6, 7. Let's count this height. 1, 2, 3, 4, 5, 6, 7, 8. 1/2 of this. 7 times 8 is 56. 1/2 of 56 is 28. So it's 28 square units. Next. Same dealio. So we do 1, 2. So it's, again, it's 1/2 base times height. So we do 1/2 of, this could be the height or the base. It actually doesn't matter. It's interchangeable. We just know that the base, we just know that this side's not in the mix. It's the two sides that form a right angle. So it's 1, 2, 3. And then it's 1, 2, 3, 4, 5, 6. Now, a little tip is if you want to make this go faster, you don't have to do it in order. You don't have to say 1/2 times 3, then times 6. It's all multiplying. So using the commutative property, we can say, well, I can just multiply this first. This is going to be easier. 1/2 of 6 is just 3. And then we have a 3 times 3, which is 9. Actually, let's just get rid of all of this. All right, last one. We have 1/2 times, let's call this the base, 1, 2 times 1, 2, 3, 4, 5. 1/2 of 2 is just 1. 1 times 5 is 5. All right, let's keep going. Word problem on finding the area of a piecewise rectangular figure. Jackie's backyard has cement and grass. Find the area of the part with the cement, which is this part. Okay. What are we really doing? We're really finding the area of this entire box, and then we're removing the grass. That's one way to look at it. Another way to look at it is, whoops, it's kind of bad, but we'll do our best with it. Another way to look at it is, this is the part, so we want all of this. We don't want this part, right? This is the part that we don't want. Another way to look at it is, I can break this up. into two rectangles. I could calculate this rectangle up top and then this rectangle down here. I'm going to tell you to do it a different way. This way I think is better for these types of problems. I'm going to say calculate the area of the entire rectangle, calculate this area, and then just delete it from the whole. So what's the whole area? Well, it's 5 times 6, so the entire guy is 30. The smaller one is 2 times 3, which is 6. Then we do 30 minus 6, which is 24. Now, if I wanted to do it the other way, you'll see we get the same answer. This rectangle up here is 2 by 6, which would be 12. This one down here would then be the remainder of 2 out of 5, which is 3. 3 times 4 down here, which is 12. 12 plus 12, 24. So we get the same answer, but the first way, I believe, is easier. All right, next question, same deal. I'm going to use that subtraction method that I just showed you. So we want the area of the grass, not the sand, right? The area of the part with the grass, yeah. Okay, so this is 2 by 2. So let's calculate the area of this entire thing, which is 4 by 6. So the area of the entire thing is 4 times 6, which is 24. The area of this little guy over here is 4, right? So if we want to do 24 minus 4, we get an area of 20. All right, and last one. Henry's backyard is a patio and garden. Find the area of the garden, which is the green. So again, we're going to do the same setup. So this is 4 by 2. This is 5 by 5. The area of the entire square is 5 times 5, which is 25. The area of this little portion here is 4 times 2, which is 8. Now we want to subtract that 8 from the 25. And we get 17. All right. Let's start. Identifying outliers and clustering. Oh, whoops. And clustering in scatter plots. Shown below are scatter plots for the 4 data sets. Answer the questions that follow. Choose the data set that has an outlier. First of all, what is an outlier? An outlier is a piece of data that literally lies outside the general pattern of the data, that lies outside of what we could predict. So like if we look here, we've got a pocket of data here, pocket of data here, pocket of data here. We don't have like one piece of data that's just randomly somewhere that doesn't make sense. Same with this. This kind of follows a pattern of a line. All of these look pretty good. None of them look like outliers. Same thing here. We got pockets, 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 but bunches together, not one just like thrown randomly. But then look at figure 4. We've got this nice line, this nice pattern, and then boom, that's our outlier. Therefore, figure 4 is no good. Choose the data, is not no good, sorry, is the one with the outlier. Choose the 2 data sets that show clustering. Clustering is when data bunches together. Like I said, when we get these pockets of data, this is clustering. This isn't exactly clustering because it's sort of spread out. But we see that for this x value, we've got 2 little clusters, and this 9 value, we have a cluster here. So the 2 ones that are show clustering are 1 and 3. Next, choose the data set that has outliers. I don't see an outlier here. This is clustering. Clustering. Here's the outliers. We got 2 outliers, and that's figure 3. Choose the 2 data sets that show clustering, 2 and 4. Last but not least, show the 2 data sets that have outliers. I see outliers here. Boom, boom. I see an outlier here. none here, none here. So it's 2 and 3. And then the data set that shows clustering is this guy. Clusters, clusters. So let's say figure 1. All right, let's keep going. Probability involving choosing from objects that are not distinct. In an aquarium, there are 6 large fish and 8 small fish. Half of the small fish are red. Okay. Half of the small fish are red. So 4 red of the small. 1 fish is selected at random. Find the probability that it is a small red fish. So probabilities, again, is the number of ways to win or number of ways to get what we want out of total outcomes. So what are the total outcomes we can have? Meaning how many total fish are there? 14, right? 8 small, 6 large, and there's 14. How many small red are there? 4. 4 small red. Therefore, we have 4 ways to win. There are 4 things that we want. So 4 out of 14, and then if we want to reduce this fraction, we can divide the top and bottom by 2 and reduce it down to 2 out of 7. That's simplest form. Next, Cheng is going to watch a movie in his collection. He has 3 action movies, 4 comedies, and 5 dramas. He will randomly select 1 movie. What is the probability that the movie he selects is not a comedy? So we don't want a comedy. What is the number of ways that we don't get a comedy? Well, we can get 3 action, 5 dramas, so that combines to be 8. And the total number of outcomes is 12. So it's 8 out of 12, but we can reduce by dividing both sides, the top and bottom, by 4, and we get 2/3. Last but not least, the box is filled with 9 red, 5 blue, and 8 yellow. A crayon is chosen at random. Find the probability that it is blue or yellow. So we can win by choosing a blue or a yellow. So the number of ways we can win are 5 plus 8, which is 13, out of a total of 22, right? 9 plus 5 plus 8 is 22. We cannot reduce this fraction. Therefore, it's 13 out of 22. Good. Keep going. Translating a phrase into a 2-step expression. Translate this phrase into an algebraic expression. 47 less than twice Jimmy's height. Now this is really tricky. Whenever we have that less term, a lot of people instinctually think it's 47 minus 2 times Jenny's height, right? Or 2 times little j, let's say. But this is wrong. Because if you think about it, what's $47 less than 100? It's not 47 minus 100. It's 100 minus 47, which is 53. Like, what's 10 less than 20? It's 10. It's not negative 10. What's 10 less than 100? It's 90. So in fact, when we hear 47 less than blah, 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 it's this 2 times Jenny before minus 47. And that's how we translate this. So 2 times j minus 47. The sum of 23, sum is just addition, so the sum of 23 and twice Carlos's score. That's 2 times Carlos's score. That's it. Just literally changing it into arithmetic or algebraic expression. 8 less than whatever this is. Remember, that means we're subtracting 8. It's not 8 minus. 8 is 8 less than the product of 11 and go around savings. Product is multiplication, so that is 11 times g. And it's 8 less than this, so we're subtracting 8 from this. And that is our answer, 11 times g minus 8. All right, cool. Let's keep going. Addition or subtraction of fractions with different denominators, I'm assuming. Yeah. So we've got 3/5 minus 2/7. We cannot do this because these two denominators are different, so we need to get them to be the same. The way we do that is we figure out what's their least common multiple. Now, these are relatively small numbers, so we don't have to use a factor tree. We can kind of probably guess and figure it out. Since they're both prime, it has to be the product of these two guys. If you can't figure that out, you can just plot out multiples of 5 and 7, and you'll see that 35 is where the two meet up. Now, does it matter that I'm choosing the smallest or the least common multiple, least common denominator? No, it doesn't. We'll still get the right answer. You'll just have to reduce later. Like I could have chosen 70. 70 would also work. But this is the least common denominator. It's just a little bit less work if you find it. So how do I get 5 up to 35? Well, I multiply it by 7. But remember, in fractions, anything I do to the denominator, I have to do to the numerator here. And we can only use multiplication or division to modify fractions like this. Same thing here. I'm going to multiply it by 5 to get it to 35, but do the same to the top. And now I've got 21 over 35 minus 10 over 35. Now this is doable. Now I can subtract the numerators, which I get 11. Denominators stay the same. My final answer is 11 out of 35. Okay. 5 over 6 plus 3 over 8. These guys are different. Where can we take them to where they'll both be equal? 24 is probably the closest one. 48 would also work. There's other ones that will work, but smallest least common denominator is 24. So I'm going to multiply this guy by 4. And I'm going to multiply this guy by 3. This becomes 20 over 24 plus 9 over 24. Which gives me 29 over 24. But simplest form usually means a mixed number. Now, this is an improper fraction. This is larger than the denominator. How do we rectify that? We see how many 24s can we pull out of 29. We can pull 1 out. And when we pull that 1 out, what do we have left in here? We have a 5 left over, which is still going to be stuck on top of that 24. So our answer is 1 and 5, 24ths. All right, here we go. Last but not least, 4/5 minus 3/8. What's my common denominator? It's going to be 40. In this case, you can always go to what is 5 times 8, and you can figure out the least common multiple, or 8 common multiple. In this case, it also happens to be the least common multiple. So I'm going to multiply this guy by 8 and 8, this guy by 5 and 5 to get both of these up to 40. This becomes 32 over 40. Minus this becomes 15 over 40. 32 minus 15 is simply 17, and that is 17 over 40. We can't reduce it. Oops. And we're done. Okay. Finding a unit price. Now I can see it starting to slow down. Justin purchased 29.4 centimeters of wire for $14.70. Find the unit price in dollars per centimeter. The key is look at the placement of the units. It's dollars per centimeter. What comes after the per, that's what we're dividing by. So therefore, I'm dividing the dollars by the amount of centimeters. Take our calculator. We've got 1470 divided by 29.4, right? And that's it. So it's to the nearest cent. So this is 0.5, and then the 0 cent, since there's nothing there for the cent, we put as 0. It's 50 cents. All right, next one. Now I'm going to show you that we can just jump straight to what it's asking. It's asking to find the unit price in dollars per pound. That means divide dollars by the pounds. It's that simple. 19.62 divided by 3.6, which equals $5.45. Last but not least, $3.68 for a pack of 16 pencils. We want dollars per pencil. So $3.68 divided by 16 equals 23 cents. And done. All right, outstanding. So now let's continue. What I'm going to do is I'm going to do a quick log out and log back in. I can see that this is slowing down a little bit, so to speed it up, I found that that works really well. And then now we go with okay, introduction to solving a linear equation with a variable on each side. So I usually say for linear equations like this, or one single variable equations, we just got to isolate that variable. The problem is we've got two variables to isolate. So now we have a first step which precedes isolation, which is called consolidation, where we got to get these two separate variables together. So I got to move this entire term over here so the v's are together. So how do I move an entire negative 5v over? I combine it with a positive 5v, meaning I combine it with its opposite. Do the same to both sides. 5v plus negative 5v is 0. 3v plus 5v is 8v equals 64. Now I isolate v. So 8 is multiplying v, so I do the opposite. I divide both sides by 8, and I get v equals 64 divided by 8, which is 8. Same deal here. I've got a v over here that I need to move over, so I'm going to subtract that v from both sides. Now this is just not a v, that's really a 1v. So it's 6v minus 1v, that's 5v equals 15. Now I want to get this v by itself. It's multiplying a 5. Let's divide both sides by 5. And we've got v equals 3. Last but not least, we've got 5u equals 45 minus 4u. How do I consolidate these? Well, we're subtracting a 4u. Let's do the opposite of that. We're adding 4u to both sides. And we get 9u equals 45. Let's divide both sides by 9. Since 9 is multiplying the u, we do the opposite, which is divide. And u equals 5. Cool, let's keep going. Use the graph to determine the behavior of the function. So this is finding where a function is increasing, decreasing, or constant. All right, cool. So what's the distinction? Increasing is literally where we have what's called a positive slope. From left to right, we're going up. This is increasing. Whoops. Decreasing is the other way. It's going down from left to right. We're talking about constant, we're talking about flat. no slope is constant, because if we look at the y value from here to here, the y value is not changing, it is staying constant. So let's look at this function, let's figure it out. So where is this function constant, first of all? Or, well, it's looking at between a and b. What's happening? Well, it's flat, just like here. Oh, let's write constant so we know. Between a and b, we're talking constant. What about b and c? What's happening here? We're going down from left to right. That is decreasing, so we're talking this guy. C and d, even though it's small, it's going up from left to right, so it is increasing. And then d and to e, again, once again, is constant. Now let's keep this up here. All right, same dealio. From A to B, positive slope increasing. Right, B to C, even though it's slightly, we're going down from B to C, so that is decreasing. C to D is flat, so that is constant. And D to E, again, we're dropping down from left to right, so that's decreasing. Okay, let's look at A to B. A to B, we're going up, that is increasing. B to C, we're going down, that is decreasing. C to D across, we're staying flat, that's constant. And then D to E, we're going down, which is decreasing. Okay, let's continue. Determining if figures are related by a rotation. Let's start this. In each part, rotate the solid figure about the origin exactly onto the dash figure. If this is not possible, click not possible. Okay. So we can kind of see, you see how this moves? This rotates it. So we're pushing it around, and let's see if it's even possible. And boom, oops. It is possible. You see that? So we rotate it right around, and that works. I think there's just one here, right? No, there's two. Okay, let's try this one. I think it's... No, it's probably not possible, but I'm going to show you why. The reason why I'm saying that is because I can see this is only one away. This seems to be... Oh, no. This actually might be possible. Let's see. Yeah, it is possible. Okay. All right, next one. And remember, when we're talking about a transformation of a rotation, you see its position relative to the origin stays constant. That's what a rotation is. Well, look at this. I can't get it to match up, therefore not possible. What about this guy? Let's bring it around, bring it around, bring it around. So close, right? It's not the same figure, so it's not possible. Last but not least, let's bring this guy around. Boom, perfect fit. Oops, perfect fit. And then we got to do this one up here. So it's definitely not going to work, so we'll bring it around, and you can see it doesn't match up. Okay, determining if figures are related by a dilation. What's a dilation? A dilation. Okay. So a dilation is basically where we can, it's an expansion, or it's like shrinking or growing a figure. So in each part, we're dilating to see, dilate the solid figure exactly onto the dash figure. If this is not possible, click not possible. So let's see if this works. This doesn't make sense, actually. This is definitely not a dilation, because watch what's going to happen. This is like a scale factor, and we're going to increase it. And obviously, it's not going to work, right? This is a translation. We've slid, or we've moved it this way and moved it this way. It's not a dilation. You see, a dilation is like shrinking or growing this. This could be shrinking it, and then this is growing it. So no, not possible. What about this guy? I don't know. It's 1/4. It doesn't look like it's possible, but let's try it anyways. Yeah, this is not going to work either, right? Next one, definitely not possible, right? It's longer than it's taller than it is wide, and this is the opposite, so there's no way this will work. But you can see it kind of doesn't match up. This one is a square. This one is a square. I'm guessing this will work, but let's try it out. Oh, wait. So now we're going the other way, right? It's a bigger one, and we're shrinking it down, which is another dilation. And boom, it worked. This will definitely not work. This is, again, a slide. It's not a dilation, because as we bring it closer, it's going to miss it. It's going to go too small. So not possible. And this one, I think, might work. Let's see. Yes, it works. All right. Area of a piecewise rectangular figure. Find the area. So again, when we're talking about something like this, we just want to break it up into different pieces. So we got 4 by 8 by 9 by 5 by 5. And what's this missing piece? We don't know what this is. Well, we know that this section down here is 5. We know that this section over here is 8. So to go all the way to the bottom, this missing piece has to be 3. So this is 3 right here. Now this line I just made also broke this rectangle up, or this piecewise, this shape up into 2 rectangles, which is what we want. And now I'm going to put this 5 out here. Now we got to calculate the area of this rectangle, and add them. What's the area of this rectangle? Well, this rectangle is 5 by 3. 5 times 3 is 15. So we got an area of 15. What about this rectangle? This rectangle is 4 by 8. 4 times 8, which is 32. And now we add these two together. 32 plus 15 is a total area of 47. Find the area of the figure. Let's go like this. 5, 5, 4, 9, 9, and 14. Okay, now we can do this a couple different ways. I'm going to just arbitrarily, actually, you know what? I'm not going to do that. I'm going to do it like this. Okay, so now let's cut this up. I cut it up into 3 rectangles. What's the area of this big rectangle? Well, it's 5 by 9, right? 9 by 5, so it's 45. This one is also 45. Then we just got to figure out what's this little guy in here. Well, it's 4 across, but what's this height? It's not 9. 9 is the whole thing. The height is, if this whole thing is 9 and this little piece here is 5, the remaining way up must be 4. So this is 4 by 4, which is a square of 16. Now we got 45 plus 45 plus 16, which is 90 plus 16, which is 106. Next, find the area of this figure. So let's do it like this. We've got this, this. We've got 3 by 4 by 3 by 3 by 3 by 4 by 3. Okay. So we've got 4, 4, 3. That's 4 plus 4 is 8 plus 3 is 11, meaning this whole bottom side here is 11. There's a reason why I'm doing that. I'm going to now split this up as follows, and we want to calculate the area of this guy up here and this guy down here. This looks like a square. It's 3 by 3. So 3 times 3 is 9 up here. What's this guy? 3 times 11, right? Height of 3, width of 11, that's 33. 33 plus 9 is 42. All right, next. A box contains 10 cards. So this is probability. Whoops. All right, so we got data analysis of probability. This is probability involving one die or choosing from n distinct objects. A box containing 10 cards is this thing. One card will be randomly chosen. What is the probability of choosing a letter from L to Q? So from L to Q is 1, 2, 3, 4, 5, 6. So there's 6 ways to choose a letter from L to Q. You could choose L, M, N, O, P, or Q out of a total of a universe of 10 cards. Probability is 6 out of 10, but we can simplify by dividing top and bottom by 3, and we get 2. Oh, not by 3, excuse me. But divide by 2, and we get 3 out of 5. Next, a bag contains 7 balls labeled 1 through 7. 1 ball will randomly be picked. What is the probability of choosing an even number? Well, let's figure that out. How many evens do we have? 1, 2, and 3. So we have 3 ways to choose an even out of a total of 7 balls. That's probability, number of ways to win out of total. So we've got a probability of 3 over 7. Last but not least, the bag contains 10 tiles. So again, my universe of options is 10. 1 tile will be randomly picked. What is the probability of picking a vowel? What's a vowel? A vowel would be like A, E, I, O, U. Well, I only see 2 vowels. I see an E and an I. So I've got 2 ways of choosing a vowel. So it's 2 out of 10, which reduces to, if we divide the top and bottom by 2, reduces to 1 over 5. All right, nice. I'm going to take a stretch break. Hold on. Boy. Okay. Let's see where we're at in terms of, if we got any questions. I didn't see. Stalin, yo, what's up? Are you still watching? I don't know if you are. I missed these comments. One of my students. All right, let's keep it going. Let's keep it rolling. Multiplication of 3 fractions. So I'm going to write it out up here. 4 over 11 times 2 over 3 times 3. Not just 3, but 3 over 1. Every whole number, I'm going to put it over 1. Now, I can go ahead if I want and just multiply across, and that's fine. But when we have something like this, it's usually better if we can look for ways to reduce the fractions before we multiply, meaning we're looking for common factors across the top and bottom. Because I see a 3 and a 3 up here, those can both be divided by 3, and those can both go to 1. Anything else? No. Prime number here, 4, 2, nothing else. Now we multiply across. 4 times 2 times 1 is 8. 11 times 1 times 1 is 11. Had I not reduced the 3, wouldn't have mattered. 4 times 2 times 3 would be 24 over 11 times 3, which is 33. Then I'd go ahead and divide the top and bottom by 3 anyways, and I'd still end up with 8 11s. So this is easier, but you can still do it this way as well. Four ninths times 3 sevenths times 5 over 2. I see common factors here, so I can divide the top and bottom by 2 and get 2 over 1. I see here we can divide 3 and 9 by 3, so I get 1 and 3. And now let's multiply. 2 times 1 times 5 is 10. 3 times 7 times 1 is 21. So it's 10 over 21. Last but not least, 4 over 5 times 7 over 9 times 1 over 2. Okay, here we go. Let's reduce. 4 and 2 can be divided by 2, so we got 1 and 2. I think that's it. So now it's 2 times 7 times 1 is 14. Over 5 times 9 times 1 is 45. And this can only be divisible by 2 and 7. This is by 5 and 3. And 3 again. So not reducible. 14 over 45. And done. Decimals. Converting a mixed number with a denominator of 2, 4, or 5. Okay. So first of all, we always have the option of turning this fraction to a decimal by division. We can just divide the numerator by the denominator, but there's a little bit of an easier shortcut here. If we can get that denominator to equal 10 or 100, this is much simpler. So look, I can get this to equal 10 pretty easily. I can multiply the top and bottom by 2, and I get 7 6/10. Why is this good? Because when this is over 10, or multiple of 10, I know that the 10th spot is right after the decimal. So this 7 clearly just goes in the 1 spot. And now since it's 6 over 10, I just put it right here. My answer is 7.6. For this one, it's 26 1/2. I can get this same thing up to 10 again by multiplying the top and bottom by 5. And I get 26 5 over 10, 5/10, so it's 26.5. You notice the whole number just stays in the answer. You just convert the fraction to a decimal. And then next we have 19 1/5. So convert that 5 to a 10, so I'm going to multiply by 2 and 2. We get 19 2/10, which is 19.2. U.S. customary weight conversions with whole number values. Okay, 144 ounces is how many pounds? So we're trying to go from ounces to pounds. So I know that I'm going to make my little proportion here, pounds and ounces. I know that 1 pound equals 16 ounces. And we're trying to get 144 ounces into pounds. Set this up, now we cross multiply. 16 times x is 16x equals 144. Divide both sides by 16, right? We're isolating x. And we get x equals 9. Okay, next 4 tons into pounds. So let's reuse this whole proportion setup here. I'll just keep pounds on top, and I'll put tons down here. So we've got 1 ton equals 2,000 pounds. We want 4 tons equals how many pounds? Let's cross multiply, and we get 8,000 equals 1x, or x, and that's our answer, 8,000. Okay, same thing, ounces, pounds, tons. So let's do pounds and tons first. We've got 2,000 pounds equals 1 ton. We've got 14,000 pounds equals x tons. Now, another way we can do this is we can realize that 2,000, to go from here to here, we got to multiply by something. And clearly, we're multiplying by 7. 7 times 2,000 is 14,000. Which means to go from here to here, we have to use the same multiplier. So it's 1 times 7, which means 14,000 pounds is 7 tons. Okay. Now let's take all this away. And now we're not going to do tons, we're going to use pounds to ounces. So again, we know that 1 pound is 16 ounces. And we're trying to find 48 ounces to x. It's the same deal. We can use that same multiplier. To get to from 16 to 48, we got to multiply by 3. Therefore, we must multiply this by 3 as well. Therefore, 1 times 3 is 3. So 48 ounces is 3 pounds. This one I'm going to blaze through. This is 96, and this is 5. Okay, metric distance conversion with whole number values. It is 5 kilometers from Dan's house to the nearest mailbox. How far is it in meters? So basically, 5 kilometers is how many meters? Well, think about it like this. Kilo means 1,000. So 1 kilometer is 1,000 meters. 5 kilometers is 5,000 meters. Next, during a huge snowstorm in the White Mountains, it snowed 400 centimeters. How much did it snow in meters? So the way we can do this conversion, we put it over 1, and then we want to convert from centimeters to meters. Why did I place the centimeters on the bottom? Because it's on the top here, and just like with fractions, we can cross off like units. So that's how we determine the placement. But then we need to make an equivalency here. How many centimeters equals 1 meter? It's 100. I'm always setting the larger unit to 1, and then the smaller unit, whatever equals that, so 100. Cross off the centimeters, multiply across, and we get 400 over 100, which reduces to 4. So it's 4 meters. Last but not least, 80 decimeters. How long is the cable in meters? So again, we're converting away from decimeters, so the decimeter is opposite there, up to meters. But what is a decimeter? A decimeter, well, the equivalency between the two is there are 10 decimeters in 1 meter. All right, you see how this always equals 1, because these two are equal. Now we get rid of the decimeters, and we multiply across, and we get 80 over 10, which reduces to 8 meters. Solving for a variable in terms of other variables using addition or subtraction. Okay, we need to solve for b. What does this mean? We just need to, when we say solve for b, it means isolate for b. It's the same thing. So we have a 12 on the same side as b. We need to get rid of that 12. How do we do that? 12 is being added to b. We do the opposite, which is subtract both sides by 12. And we get b equals a minus 12. And that's it. That's all there is to it. A minus 12. Next we have x minus y equals r. We're trying to solve for x. So we got to get x by itself. We need to move this y over. Y is being subtracted from x, so we'll add a y. We'll do the opposite. Negative y plus y is 0. X equals r plus y. Last but not least, we have x equals y minus 18, and we need to solve for y. So y is subtracting 18, or 18 is being subtracted from y. The opposite of that is adding 18. So we'll add 18 to both sides, and we've got y equals x plus 18, and that's it. Okay. Additive property of inequality with whole numbers. X minus 2 is less than 17. So we need to solve this for x. So basically, again, that means isolate x. So how do we get the x by itself? We need to move this minus 2. So 2 is being subtracted, so we're going to add 2 to both sides. We got x is less than 17 plus 2, which is 19. The inequality symbol stays the same. Just like if we were solving for an equation with an equal sign. Same thing. right, next. So for v, 20 is greater than or equal to v plus 8. 8 is being added to v, so I'm going to subtract 8 from both sides, and I've got v is less than or equal to 12. This is the same as saying v is less than or equal to 12. Basically, the orientation of this inequality has just got to face the same way with respect to v. So both of these will give me the right answer. I'll enter it the first way. Greater than, so v is less than or equal to 12. It's very important you retain that sign down there. And there we go. $25 is less than or equal to w minus 10. So 10 is being subtracted from w. Let's add 10 to both sides. Add 10 to both sides. And we get w is greater than or equal to 35. Now I'll write it the other way and show you it still gives you the right answer, right? Just as long as this orientation is the same towards w, it's still correct. Operations with absolute value, problem type 1. All right, so what is absolute value? Absolute value is my positive purifier. Let's put the absolute value bars in red. Oops. Okay, so what's going on here? First of all, we have to apply the absolute value in this case here before we do the addition. Absolute value of -7 is +7, right? It just purifies it of the negativity. So what's 7 plus 4 is just 11. Simple as that. But here's a little different. We don't apply the absolute value until these whatever happens in here happens. So first we combine a -7 with a +4. It's a subtraction problem. 7 minus 4 is 3. The negative dominated, so it's a -3. Now we apply the absolute value. Now we apply the positive purifier, and we get +3 out. So this one becomes 11, and this one is 3. Next. We have -2 plus 7 within absolute value. Here we have -2 plus 7. So first, let's evaluate what's inside. Add this up. -2 plus 7. It's just like 7 minus 2, which is 5. Absolute value of 5, since it's already positive, positive purifier doesn't do anything. It still stays positive. The final answer is 5. And now here we apply the absolute value first. That -2 becomes a +2. Then we add that to 7, and we get 9. All right, last but not least, 5 minus 7, 5 minus 7. Let's apply the absolute value first. We get a +5, and then a +5 minus 7 is actually -2, right? 5, it's like 7 minus 5, which is 2, but the negative dominates, so it's a -2. Here we do 5 minus 7, which is -2. Then we apply the absolute value. Positive purifier makes it +2. Okay, division, let's see, involving a whole number and a unit fraction. Okay, so first of all, 1 over 10 divided by, I'm not going to say 3, I'm going to say 3 over 1. Okay, why? Because I'm going to show you something called keep, change, flip. When we have fraction division, this is how it goes. 1/10 divided by 3 over 1. Keep, change, flip means we keep the first part, we change the second part to multiply, and we flip the third part to 1/3. Then we evaluate this. 10 times 3 is 30. 1 times 1 is 1. And we get 1 over 30. That's how you do fraction division. What about this guy? Let's fill it in and redo it. So we've got 3 over 1 divided by 1/10. Keep, change, flip to 10 over 1. 3 times 10, 1 times 1, we get 30 over 1, or just simply 30. Okay, next. Oops. All right, same dealio. 1/9 divided by 5 over 1. 5 over, oops. This becomes 1/9 times 1/5, which is simply 1 over 45. And then this one is 5 over 1 divided by 1/9, which is 5 over 1 times 9 over 1, which is 45 over 1, which is 45. Oops. Last one, 9 divided by 1/4 is the same as, oops, 9 over 1. 9 over 1 times 4 over 1, which is 36 over 1, or 36. And this is 1/4 divided by 9 over 1, which is 1/4 times 1 over 9, which is 1/36, or 1 over 36. All right, cool. So I'm noticing a lag again. I'm going to log out and log back in. Okay, I'm going to take a stretch break. 1 second. Back to it. Oh, looks like we've done 4% so far today. That's not bad. 267. Okay. Let's keep going. Graphing a linear inequality on the number line. Okay, so what we're seeing here is we see a is greater than or equal to -9. So the first thing to do is look at this symbol. Is it just greater than, or is there a line underneath it? The line indicates greater than or equal to, which means it's inclusive of whatever the other value is on the other side, which means -9 is not just a barrier, it's part of the solution set. So that means we choose the filled in circle. This indicates that -9 is a solution. But then it also says a is greater than or equal to -9. Greater than is, well, what's greater than -9? It's all these values to the right. 11, 10, 9, 8, -1, -2, all these. So then we know that's the side where we got to shade it in. And you see that this arrow over here, did it work? Yeah, I think it did. That arrow over here indicates that we're including all the values upwards and onwards beyond that point. Okay. Next, y is less than 10. So this is not inclusive of 10. So we put a hollow dot to say that 10 is where the solution set starts, but it's not including 10. So 10 is not part of this, but it's everything below 10. Last but not least, a is greater than 4, not including 4. So there's the point. Everything above 4 is good, and we are done. All right, translating a point and giving its coordinates 2 steps. First, translate the figure 6 units to the right. 1, 2, 3, 4, 5, 6. And that makes sense, right? From 6 plus -5 takes you to +1. And then 8 units up. So I'm going to say, look where we're at. We're at -2 vertically, and we're going to go up 8. That's going to take us to 6, but now let's count it out. 1, 2, 3, 4, 5, 6, 7, 8. And that's what we projected. Then give the coordinates of the marked point in the original figure and the final figure. Original figure looks like -5 on the x, -2 on the y. -5, -2. And then the point in the final figure is 1 and 6. 1, 6. Okay, next. Okay, first we're going to translate the figure 7 units to the left. So look where we're at. We're at 2, and we're subtracting 7. So 2 minus 7 is going to take us to -5. 1, 2, 3, 4, 5, 6, 7. And then 4 units up. 1, 2, 3, 4. So let's do the original coordinates, which is 2, -6. So I'm always doing the y first. 2, -6 on the y-axis. And then the new one is -5 on the x, -2 on the y. -5 on the x, -2 on the y. You know, just to show you what we could do, we can already figure out the coordinates here. You know, as a shortcut, you could say -4, 6. That's the coordinates. We're going 8 units to the right, which means we're adding 8 to the x, and we're going 6 units down, so we're subtracting 6 from the y. And then we can add these. -4 plus 8 is 4. 6 plus -6 is 0. We already know now our new coordinate is 4, 0. This is our old one. So that's another way to do this if you want. And we can take it right to 4, 0. All right, let's see if I make sure I did this correctly. Well, we'll give it a shot here. -4, 6. And we've got 4, 0 down here. I think that's right, right? Okay, let's see. Okay, cool. Multiplicative property of equality with decimals. So 6.4 equals v divided by 4. How do we do it? We need to solve for v. What is the v? What's happening between the 4 and the v? How do we isolate it? The v is dividing the 4. What's the opposite of division? Multiply. So I'm going to multiply both sides times 4. This cancels out. And then we just got to do 4 times 6.4. Which is 16 carry the 1, 24, 25. We got 1 decimal point, so move it over, and the answer is 25.6. Y over 5.12 equals 2. Same thing, y is dividing the 5.12, so we're going to multiply. We're going to do the opposite, multiply both sides by 5.12. And we get y equals 10.24. Okay, last but not least, phi w equals 12.5. What's the 5 doing to the w? It's multiplying. Opposite of that is dividing. So I'm going to divide both sides by 5, and we get w equals 2.5, I believe. Because 5 goes into 12 twice, and then what's left over is 2.5, which is half of 5. So this is 2.5. All right, let's keep going. Graphing a line given its x and y intercepts. So it's got an x-intercept of 6, y-intercept of 7. What is a y-intercept? What is an x-intercept? X-intercept means this is where it hits the x-axis. So it hits the x-axis at 6. Here's the x-axis. Boom. Then it says it hits the y-axis at 7. Here's where it would hit. Voila, that's it. It's done. The line is graphed for us. That's 2 points, make a line, and we're done. Same dealio here. Y-intercept is 3, so it hits the y-axis at 3. X-intercept is 9. Done. Last question. X-intercept of 4, y-intercept of 1. That's it. Okay, estimating a square root. So it says, find two consecutive whole numbers that square root of 44 lies between. What is this really telling us is we have to figure out what are the perfect squares that lie on either side of 44. So what are perfect squares? Perfect squares are numbered. 44 is not a perfect square. There's no whole number that when times itself equals 44. So we need to find the next smallest square root and the next biggest square root. The smallest one, or the next smallest one, is 36. The next biggest one is 49. These are perfect squares. The square root of 36 is actually 6. The square root of 49 is actually 7. Therefore, the value of the square root of 44 lies in between 6 and 7. Like, that makes sense because this is in between 36 and 49. So the evaluated answer would be like 6 point something, like maybe 6.7 or 6.6, I don't know. So it lies between 6 and 7. All right, next, let's look at square root of 92. So we got to figure out what this lies between. So let's think, well, 8 times 8 is 64. 9 times 9 is 81. So maybe 81 here. 10 times 10 is 100. Perfect. That's on the other side, 100. So we know that it lies between square root of 81 and square root of 100. What does this evaluate to? 9. What does this evaluate to? 10. Therefore, this is between 9 and 10. Last but not least, square root of 130. Okay, if you're not sure, you can multiply them out, but let's try and do it mentally. 10 times 10 is 100. 11 times 11 is 121. That probably is the next one over. 12 times 12 is 144. Yes, that's perfect. It's on the other side. So we're in between these two. These two evaluate to 11 and 12. Therefore, this is between 11 and 12. Okay, find the value of x. Let's do this. We've got 84 over here, we've got 130 over here, and we got x over here. So how do we do this? This is called find an angle measure for a triangle with an extended side. So we need to know that all the angles, first of all, there's two things. All the angles in a triangle add up to 180. Also, all the angles across a straight line add up to 180. So since this is a straight line, and we know that this angle right here is 130, this angle in here must add to, when it's added to 130, must equal 180. Therefore, this has to be 180 minus 130, which is 50. Now, this is super helpful because we have two angles of a triangle, so we just got to find the third. So that means 50 plus 84 plus this x has to add up to 180. 50 plus 84 is 134 plus x equals 180. To find x, we subtract from both sides, and x equals 46 degrees. Next, we have, oops, that's bad. We have this, and we have this. We know this angle here is 132. We know this is x, and this is 53. Therefore, this missing angle in here has got to combine with 132 to be 180, so it's got to be 48, right? I'm subtracting this from 180. And now this plus this plus this has to equal 180. So 53 plus 48 plus x equals 180. These two add up to 101. Subtract 101, subtract 101. And we get x equals 79 degrees. All right, here we go. This, and this. 93, 39, x. Okay. Now we need to find the outside. This is a little different. We got two angles within the triangle. First, we need to find this puzzle piece, and then we can figure out x. So remember, 39 plus 93 plus, let's call this y, plus y equals 180, right? So 39 plus 93 is 120, 132. Subtract 132. And we got y equals 48. So this guy in here is 48. And then 48 plus x, because it's a straight line, has to, again, equal 180. So now we can subtract 48 from 180, and we get 132. Oh yeah, there's another shortcut I forgot. The other rule is that the exterior angle equals the sum of the opposite interior angles. So I could have actually jumped a step and just added these guys together and gotten 132, but this way works as well. It's just longer. Circumference of a circle. Good old circumference. Okay. So we're giving diameter, and we need to find the circumference. What is circumference? This is actually a pretty straightforward equation when we have the diameter. Circumference is equal to diameter times pi. That's it. And they want us to use 3.14 for pi. So literally, we're just doing the diameter times 3.14. We can also write this as 2 pi r, where r is the radius. But radius is literally half of diameter. So it depends on what they give us. Here they're giving us diameter, so this makes it super easy. And we got a calculator, so we just do 3.14 times the diameter. Diameter is this length across, which is 10. Whoops. 3.14 times 10, which is 31.4. Circumference is a measure of length, so it's not squared, that's area. It's not cubed, that's volume. It's just that. All right, now they only gave us the radius. Now we need to use this formula. Same thing. We can also think of it as just you double the radius, you get diameter. But this is the other way to think about it. So now it's 2 times that pi value times the radius here, which is 4. So let's multiply it out. We got 2 times 3.14. Whoops. Now remember, the parentheses here is the same as multiplication. It represents multiplication. And we get 25.12. Alex lets us copy that value and paste it in here. And again, it's just feet. Once again, they give us diameter, makes it easier for us. So it's diameter times 3.14. 24 times 3.14 equals 75.36 yards. Finding the LCD, which is the lowest common denominator of two fractions. Another way is the least common multiple of the denominators. Okay. So we got 20 and we got 8. This is the ultimate way to find LCM. And it's not always the fastest, but will work no matter what. Now you can kind of figure this out. You can kind of guess and check. And I can tell you that I know it's not 20, it's 40. Okay, but this is the prime factorization method that's really great. Because, I mean, look, you could be like, all right, we got 20, then we got 40, then we got 60. The only time where we're going to end up with a 0 in the tens place is 8 times 5, which is 40. Then we have 80, so on and so forth. So anyways, that's going to be the least common denominator. But let me show you the prime factorization method. We break this up into prime factors and just step by step. So first we got, break it up into 2 and 10. 2 is prime, 10 is not. Break this up again into 2 and 5. This is done. We got all prime numbers, it's done. This one becomes 2 and 4. This is a prime. Break this up again, and we got 2 and 2. Now, it doesn't matter how you do it. You'll get to the same prime factors no matter what. That's the beauty of it. Now we look at the commonalities. We got 1, 2 in common, another set of 2's in common, and then these are the odd ones out. So then we add a 5, and then we add that last 2. Multiply this all together. 2 is 4 times 5 is 20 times 2, and we get the least common denominator of 40. Let's do it again with this one. So we've got 10 and 7. This is going to be a little easier, but break this up into 2 and 5. Boom, boom. 7's already prime, so we just circle it. Do we have anything in common? No. We just got odd man out, so we just got a 2 times a 5 times a 7. 2 times 5 times 7 equals 70. And that's my LCD there. Last but not least, 2 and 12. Well, this is a special case where 2 is actually a factor of 12, meaning we can multiply 2 to become 12. So this means that the least common multiple of these two, or the LCD of these two, is actually 12 itself. And that's that. All right, division involving a whole number and a fraction. So we got 2 divided by 7, 6. So this is, again, keep, change, flip, and I'm going to turn this into a fraction. So if we do keep, change, flip, remember we keep this first fraction as is. We change this to multiply, and we flip this to 6 over 7, and then we multiply across. And we get 12 over 7. And that reduces to, we pull 1 7 out, which is a 1. And we've got 5 remaining, 1 and 5 sevenths. Next, we got 3 over 1 divided by 5 over 6. Let's do keep, change, flip. So it's 3 over 1 times 6 over 5, which gives us 18 over 5. How many 5s can we pull out of there? 3. And then what's left? A 3. So 3 and 3/5. Last but not least, 6 sevenths divided by 9 over 1. Every time I'm turning that whole number into a fraction. This is just 6 over 7 times 1 over 9. Now, I can multiply across, but I can cross simplify here. I can divide the 6 and the 9 by 3. This becomes 2. This becomes 3. 2 times 1 is 2. 7 times 3 is 21. So we got 2 over 21. Fraction division. Seven over 9 divided by 8 over 15. We're going to use keep, change, flip again. So this becomes 7/9 times 15 over 8. Now I'm looking before I do anything to cross simplify. Well, guess what? I can divide the 9 and 15 by 3. We have 5 and we have 3. 7 times 5 is 35. 3 times 8 is 24. Again, how many 24s can I pull out of this? 1. And what's left over? 11. If I yank a 24 out of 35, I got 11 left. And it's 11 out of 24. Oops. Next, we got 6 over 5 divided by 7 over 6. Keep, change, flip. So we got 6/5 change to multiplication, flip to 6 over 7 when we do dividing fractions. Can we cross simplify? We can't. There's nothing on the top and bottom that have common factors. So it's 6 times 6, 5 times 5. We get 36 over 35. How many 35s can I yank out of this? And at 1. And then what do I have left over when I pull a 35 out of 36? I got a 1 left. 1 and 1/35. All right, 9/4 divided by 3/8. Keep, change, flip. 9/4 times 8 over 3. 4 and 8 can both be divided by 4, and we get 1 and 2. 9 times 2 is 18. Oh, wait, I can simplify further. 9 and 3 can both be divided by 3, so this is 1 and this is 3. 3 times 2 equals 6 over 1, which is 6. Okay, graphs, functions, and sequences. Writing a function rule given a table of ordered pairs, one-step rules. Below is the table of values of a function. Write the output when the input is n. So what's happening here? We are basically figuring out what is the rule to get from the input to the output. Are we adding? Are we multiplying? And whatever the rule is, it has to be consistent for every value. Well, so from 2 to 8, maybe we're adding 6. So 2 plus 6 is 8. That works there. 7 plus 6 would be 13, not 28, so that fails. Let's try multiplying. 2 times 4 gives us 8. Cool. 7 times 4, it does give us 28. 9 times 4 does give us 36. So what's happening is we're taking the input, n in this case, and we're multiplying it by 4. So that's all we're doing. This times 4 would give us this value, whether it's 1, 2, 3, 4, 10, 20, whatever. All right, again here, it's probably, looks like it's adding, right? 4 plus 2 is 6, 6 plus 2 is 8, 7 plus 2 is 9, so that input is simply having 2 added to it. All right, last but not least, could be dividing by 4, but it doesn't look like it. It's probably subtracting and subtracting by 3. 4 minus 3 is 1. 5 minus 3 is 2. 9 minus 6 is 3. N, so it's n minus 3. Finding angle measures given two intersecting lines. Okay, this is going to be really cool because this is going to teach you some important geometric rules. Whoops. So here's 4, 1, 3, and 2. And it's telling us that angle 2 is 34. Believe it or not, we can now figure out every single angle from this. Let me put this in red here. So this is 34 degrees. The first rule to know is that vertical angles, meaning angles on opposite sides of two intersecting lines, are equal. 4 is a vertical angle with 2. It's opposite 2. So therefore, 4 is also 34 degrees. But how do we figure out 3 and 1? Well, if you notice, this is a straight line, or which also means this forms a straight angle. Straight angle has a measure flat across of 180 degrees. That means angle 1 plus 4 is 34 degrees. So if we call angle 1 x, x plus 34 is going to equal 180. Therefore, to solve for that value, we can subtract 34, excuse me, and x equals 146. So angle 1 equals 146 degrees. 146 was 34, 180. And since this is vertical with number 3, number 3 is also 146. Okay, let's keep going. All right, next we've got this, and we've got this. Whoops. 1, 2, 3, 4. Angle 3 is 136. Angle 1 is vertical to that, so angle 1 is also 136. Angle 2 plus 3 equals 180, right? This is a straight line. So therefore, angle 2 has to equal 44, because 44 plus 136 is 180. And angle 2 and 4 are vertical, so angle 4 has to also equal the same, 44 degrees. Okay. Last but not least, one, 2, 3, 4. Angle 4 is 107, therefore angle 2 is 107. What is 3? Well, 3 plus 2 has to equal 180, therefore 3 is 73 degrees. What is angle 1? Also 73 degrees. So angle 1 is 73, angle 2 is 107, angle 3 is 73. All right, graphing a line in quadrant 1. So there's two ways we can do this. We can make an x and y table. We can also use slope-intercept, but I'm going to do it this way first. All I got to do is choose any two values of x that I want. So I'm going to choose 0 and 1. It's pretty straightforward. Now I'm going to find the corresponding y values. Remember, an equation is just a relationship between x and y. There's not a single solution. There's actually infinite solutions or pairs that satisfy this equation. So what does y equal when x equals 0? Well, 2 times 0 is 0, plus 4 is simply 4. And what does y equal when x equals 1? We'll plug in a 1 here. 2 times 1 is 2, plus 4 is 6. So my two coordinates are 0, 4, 0, 4, and 1, 6. 2 points make a line, and that's that. You can also solve this using slope-intercept form, which is another method that we're going to go through at a later topic. So like my slope, for example, here is 3. It's whatever's multiplying to x. My y-intercept is 1. So I can plot the y-intercept and then use my slope to get that next point. But I'm going to do it the same method here for now. I'm going to use 0 and 1. When x equals 0, well, I know that 0 plugged in here would go to 0. plus 1, which is 1. When x equals 1, right, I'm going to do 3 times 1 plus 1. 3 times 1 is 3 plus 1 equals 4. So those are my 2 points. So I've got 0, 1, and then my next point is 1, 4. Last question, x and y. So I've got 0 and 1. If I plug 0 in for x, it's 0 plus 2, which is just 2. If I plug 1 in for x, it's 1 plus 2, which is just 3. So my 2 coordinates are 0, 2, and 1, 3. So 0, 2, right? 0 on the x-axis, 2 on the y-axis. And then 1, 3, 1 on the x, 3 on the y gives me that line, and that's that. All right, here we go. Rewrite using a single positive exponent. So what is this? This is 6 to the 8 over, is that just a 6? No, it's actually 6 to the first power. So what is the quotient rule? The quotient rule says that when we have the same base and different exponents, to get the final answer, we subtract the bottom from the top. So this is really 6 to the 8 minus 1, which gives us 6 to the 7th. Okay, next, 8 to the 5th over 8 to the 3rd equals top minus the bottom, 5 minus 3, which is 8 squared. And last but not least, we've got 5 to the 6th over 5 to the 1, which equals 5 to the 6 minus 1, which equals 5 to the 5th. All right, let's keep going. I'm seeing it slow down a little bit, so I'm going to do a quick log out and a log back in. In fact, I'm going to take a stretch break too. We're almost at the 2-hour mark. Let's see how we're doing. Anything else? Oh, Almighty Strider, awesome. I hope it does. Let me know how it goes, and let me know if you have any questions. Also, let me know if there's anything you want me to solve at some point on my live streams, different topics. So reach out to me. Great to hear from you. Okay, let me take a stretch break. Boy, I think we're gonna make it to 50%. That's my goal. That's another 35 topics. Actually, well, we'll see. Boy. Okay. Pretty much out of coffee. Now I gotta go on natural energy. Whew. Let's keep it going. Reflecting a point across both. Oh no, finding the mode and range from a line plot. Okay. So we're trying to find the mode. Now again, mode is synonymous with, or it sounds like, excuse me, most, but it is also the same as whatever value occurs the most amount of times. So we only have 2 1s, we have 4 6s, 1 7, 2 8s, 1 9. 6 is the mode, so it occurs the most times. So 6 is the most. What is the range? Range is the distance from the smallest value, in this case 1, to the greatest value, which is 9. So what's this distance here? It's just 9 minus 1, which is 8. Okay, my mode here is 7. They flipped it. And the range is 8 minus 3, which is 5. Greatest minus the smallest. Last but not least, we've got a mode of 3 occurring 5 times. And we got a range of from 1 to 7. 7 minus 1 is 6. Okay, so word problems involving addition or subtraction of fractions with the same denominator. It takes Hans 5/8 days to drive to his aunt's house. He now has been driving for 3/8 days. For how much longer must he drive? Okay. So in this case, it takes a total of 5/8, but he's already been driving 3/8. So the way we can think about it is 3/8 plus what equals 5/8, or really we're talking about taking the difference of these two fractions. So 5/8 minus 3/8 will give us the answer. What is 5/8 minus 3/8? We've got common denominators, so we just subtract the numerator, keep the bottom, and we get 2/8. But this can simplify by dividing the top and bottom by 2, and we get 1/4. A coin weighs 8/15 ounces. A different coin weighs 4/15 ounces. How much do the coins weigh together? Together, that is an addition problem. So we're just adding 8/15 plus 4/15 equals 12/15. And now we reduce because we can divide the top and bottom by 3. And we get 4/5 ounces. Next, Trey swam 2/9 kilometers to an island, then he swam 1/9 to a boat. How far did he swim in all? This is addition. We add these two, we get 3/9, and we reduce by dividing the top and bottom by 3, and we get 1/3 of a kilometer. All right, multiplicative property of inequality with whole numbers. Just like if this were an equation, we want to isolate x. So what is the x and the 8? What's the 8 or x doing to the 8? It's dividing. So the opposite of dividing is multiplying. So we multiply both sides by 8, and we get x is greater than or equal to 88. And that's it. X is greater than or equal to 88. See how I always state this in terms of the x, not the 88. I could say 88 is less than or equal to x, but it makes more sense when we do it from the perspective of the variable. Next, v over 6 is less than 9. The v is dividing the 6. Let's multiply both sides by 6. And I get v is less than 9 times 6, which is 54. And last but not least, 35 is greater than or equal to 5x, or 5x is less than or equal to 35. 5 is multiplying the x, so I'm going to divide both sides by 5, and I get x is less than or equal to 35 divided by 5, which is 7. All right. Translating a polygon. Draw the following triangle after a translation, 4 units to the left and 2 units down. Okay. So what are we going to do here? We need to translate. How do we translate it? We got to translate it coordinate by point by point. So there are 3 points, 3 vertices. So each one is going to have the same translation of 4 units to the left, 1, 2, 3, 4, and 2 units down, 1, 2. So that's that point. This one is going to go 1, 2, 3, 4, 1, 2. And this one is going to go 1, 2, 3, 4, 1, 2. Okay. Now, Let's connect the dots. Now I'm just going to do a quick spot check. Does this look like the exact same figure just moved? It does, pretty much. Just double checking, so let's go for it here. All right, cool. Translation of 2 units to the left, 2 units down. So same thing, we got 4 vertices. Let's do the same translation to each one. So we got 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2, 1, 2. Now we connect the dots. 1, 2. Look at that. It looks very good. Looks exactly the same, just shifted down and to the left, so we're good there. Last one. 4 units to the right, 1 unit up. So one at a time. 1, 2, 3, 4, 1 unit up. 1, 2, 3, 4, 1 unit up. And 1, 2, 3, 4, 1 unit up. Boom. Look at that. Looks good. I think we're golden. Okay, reflecting a polygon across the x-axis. X-axis or y-axis. So draw the reflection of the triangle across the x-axis. So what do we do here? Again, we're going to draw vertice by vertice. Same thing as we did in the previous topic. So first, how do I reflect this across the x-axis? This is my mirror. So what we do is we look and we see how far away is this from the x-axis. It's 1 unit above it. So we just go boom. We line it up in the same spot and go boom, boom, 1 unit below it right there. That's the reflection of that. What about this one? It's 7 units above at 4. So then we drop down 7 units below, same x-coordinate though, still at 4. And then this one is at 6, so we're going to stay on 6, but it's 3 units above, so we drop to 3 units below. And then now we just connect the dots. All right, let's go to the next. Across the y-axis. So now y is our mirror. We're jumping across y. So this is 1 unit to the left. We go 1 unit to the right of y. This is 2 units to the left. So we go 2 units to the right. Same thing matched up with 8. This one is matched up with 7, and it's all the way here at -8. So we're going to stay on 7 and go to +8. And then this one is at -6 for 2. We stay at 2 on the y-axis. We go to +6 and then connect the dots. See that reflection? It looks like a perfect reflection across. Okay, last but not least, across the x-axis, so we're jumping over the x again. So it's 2 below, we go 2 above. 3 below, we go 3 above. 8 below, and we go 8 above. 6 below, and we go 6 above. Connect the dots. That looks pretty good. All right, cool. Distinguishing between the area and perimeter of a rectangle. Remember, if we're talking about a rectangle, the perimeter is this length going all the way around the outside. This distance plus this distance plus this distance plus that distance. The area is all of this space kind of in the middle. So in this case, let's find the two. The perimeter is 16 by 29. 16 by 29. So that means we add up all of these. So 16 plus 16 is 32. 29 plus 29 is 58. We add them together and we get a perimeter of 90 feet. Perimeter is length, so it's just feet. What's the area? It's the product of these two. They give us the calculator. Let's use it. So 16 times 29 equals 464. Copy, paste. But area is always in square units. We think about that feet squared because we're using 2 dimensions. We're using length and width. So squared, 2. Then it says the lawn will be surrounded by a rope. Surrounded, going around, that we're straight up talking about the outside, which is the perimeter. The lawn will be mowed. How long will it take? That's all. This part inside, that's the inside area. We're talking about area. Again, let's calculate these two values, 29 and 76. Perimeter, we add all these up. So 29 plus 29 is 58, plus 140, 152. If I add 76 and 76, and then we go 0, 11. So the perimeter is 210 yards. The area is 29 times 76, which equals 2204. And that is yards squared, so that's the area. The field will be covered by artificial turf. That's all the inside. That's straight away we're talking about area. Amy will walk around the field. That's the outside. Once again, we're talking about perimeter. Okay, let's do area and perimeter one more time. $82, $69, $82. The area, we just multiply these guys. 69 times 82 is 5658. The perimeter, we add all these up. So I'm going to actually use the calculator. These are bigger numbers. 69 plus 69 plus 82 plus 82 equals 302. And again, yards. The lot will be paved, meaning they're going to put concrete all on the inside. They're talking about area. A chain will surround, going on the outside the lot. That's all about perimeter. Area of a parallelogram. $17, $13, and $13. Okay, how do we do it? We got 3 different measurements. We only need 2 of them. What do we need? This little square down here is important because this indicates that we've got a right angle. Now, with the parallelogram, it's base times height. But what's the height? We know we can maybe tell that the base is 13, right? This is what's on the ground here. But what's the height? The height is actually not 17. This would be like a slanted height. We want the height which is straight up and down from the base all the way to the top. So what they do is we extend out the base like this, and we can kind of see that the height, if this base were extended, is right here, which is 13. So we do this height 13 times this base 13, which gives us an area of 169 feet squared. And that's how you do it. Next one. Well, guess what? We got 16, 15, and 11. What's the base and the height? It's where we see that right angle. The right angle is formed between 15 and 11. So 11 is my height. 15 is the base we're going to use. We could also use 16, but then we need a different height. Like this height probably wouldn't be 11. It's something else. We don't know what it is. And frankly, we don't need it because we've got this. So 11 times 15, which is 165. And this is inches squared. Okay, last but not least, where's the right angle? Right there. So we know that the base is this value. We know that the height is this value. What's this base? It doesn't say. Well, it's equal to the opposite side, which is 13. So 13 times 6, which is 78. Let's continue. All right, identifying outcomes in a random number table used to simulate a simple event. Charmaine's video game, she received a treasure box for completing a mission. Each treasure box gives Charmaine a special item. Every treasure box has a 33% chance of having a coin, 46% chance of having a potion, and 21% chance of having a gem. Charmaine wants to simulate what could happen for the next 10 treasure boxes. Let 1 to 33 represent a treasure box having a coin, 34 to 79, a potion, and 80 to 100, a gem. Okay, so that's 21, and then that is, I see, 33, no, 46, and then that is 33. Okay, so these are like percentages. A random whole number from 1 to 100 is generated for each simulated treasure box. Okay. This is complicated, but I get what they're saying. They're basically showing you how to figure out what's going to happen if we go through 10 treasure boxes. Like, what's the likely outcome of what we're going to get, of what the items are you're going to get. So anytime we're in between 1 through 33, we're going to get a coin. Anytime we're going to be in between 34 to 79, a potion, and 80 to 100, we're going to get a gem. So which item was in each treasure box? So what's in treasure box 3? It's 67. That's in this range, right? Between 34 and 79. So we're talking about a potion. Treasure box 9, we generated an 84. That's in this zone, which is a gem. Treasure box 10, which is a 4, which is in this zone, which is a coin. Really strange question, complicated question in terms of the verbal setup, but you can see it's really not that bad once you break it down. I am going to skip over this stuff here because I can see that the meat of the question is really here. The percentiles correspond to this, but it doesn't really matter. Once we have this, I know this range is a macaron, this is a macaroon, this is a scone, this is a cheesecake. So for customer 3, we're at 69, which is in this zone, right? So between 58 and 76. So customer 3 got a scone. Customer 4 gets a macaroon. And customer 10 gets a macaroon as well. Okay, last but not least, winner 1 is 74, which is in this zone, right? 32 to 79. So that's a shirt. Winner 4 gets a 9, which is down here, which is cotton candy. And then winner 10 is up here, 95, which is a keychain. All right, word problem involving multiplying a fraction and a whole number. Okay, Ahmed jumped up 9 steps. Each step was 7/10 of a foot high. How high did he jump up altogether? This means he did 9 times 7/10, 9 of them. I'm going to turn this into an improper fraction and then multiply. So we multiply the numerator, multiply the denominator, and we get 63 over 10. Simplest form. How many 10s can we pull out of 63? I can pull out 6, and I have that 3 remaining. So we have 6 and 3 tenths. Okay, next we have 5/9 liters of soda. Donna has 3 of these bottles. So to figure this out, I got to multiply 3 times 5/9. Now I can multiply across, or I can simplify first. Let's simplify first. We can divide 3 and 9 by 3. This becomes 1. This becomes 3. 1 times 5 is 5. 1 times 3 is 3. How many 3s can I pull out of 5? 1. And I have 2 left. 1 2/3 liters. Oops. A coin weighs 3/4 of an ounce. Hong picked up 6 of these coins. This is a multiplication. What is the total weight of the coins he picked up? Multiply, multiply. Let's cross simplify. Divide the top and bottom by 2. We get 2 and 3. 3 times 3 is 9 over 2. How many 2's can we pull out of 9? 4. And we have 1 left over, so 1/2. Right? It's basically how many times does 2 go into 9? 4 times with a remainder of 1. So it's 4.5 ounces. Okay, next, signed fraction multiplication basics. The idea with multiplication and positives and negatives is a negative times a negative, positive. Positive times a positive, positive. It's a positive times a negative gives you a negative. So anytime basically you have a negative in the mix and the other one's not negative, the negative takes over, dominates, and infects. The final answer is negative. So 8, I'm going to make this over 1 times -5 over 2. Now we cross simplify the same way. We still can, even though this is negative, we still cross simplify the same way. Divide the top and bottom by 2. We get 4 and 1. Multiply cross, we get 20 over 1. But since we got a negative in the mix, this is negative, which is just negative 20. Okay, next. 4 over 7 times -1 over 8. Again, let's cross simplify. Divide the top and bottom by 4. We get 1 and 2. 1 times 1 is 1. 7 times 2 is 14. So we got a negative. This is negative. -3/7 times -8 over 1. Can we cross simplify? No. But look, we got 2 negatives multiplying each other. They nullify each other, cross out to become positive. 3 times 8 is 24 over 7. Can we reduce this? Yeah. Or simplify? Yeah. How many 7's can we pull out of 24? We can pull out 3, because that would be 21. And then we have a 3 remaining on top that stays above the fraction. So we got 3. Whoops. Wait, it doesn't give us the option to do an improper. So in this case, since it doesn't give us that option, I'm just going to say 24 over 7. I guess it doesn't want us to reduce. Let me just make sure I didn't make a mistake. Yeah, I don't know. All right. Converting a decimal to a mixed number and an improper fraction without simplifying. So 2.5. It's important to understand what these decimal places are. So I'm going to put like little dot lines here. This is, of course, the ones. This is the tenths. This is hundredths. And this is thousandths. Okay. So when we're doing it as a mixed number, this always just comes down and stays as is. 5, since it's in the tenth spot, is literally 5/10. So we don't simplify. We know that, we know that this is 2 and 5/10. What about here? As an improper fraction, we want to convert it to an improper fraction. We take the mixed number. We multiply 2 times 10, 2 times the denominator, and we get 20. Add it to the numerator. This goes away, and we have 25 over 10. Okay, next. Oh, you know what? I want to keep this here. Now we've got 6.01. Where does the decimal place, where does this decimal stop? In the hundredth spot. So we've got 6 and 1 over, not 10, 100. Okay. 6 and 1 100th. So let's write this as a mixed number. What about as an improper fraction? Take this 6 multiply it by 100, and we get 600. Add it to the numerator. We get 601 over 100. Okay, 5.82 as a mixed number and as an improper fraction. So again, oh wait, I want to keep that. I keep forgetting. We got 5.82. Again, we got a 5. Where does this decimal stop? In the hundredth spot. So we got 82 over 100. 5 and 82 over 100. Improper fraction, we multiply it against the denominator and we get 500. We add it up here. And we get 582 over 100. Next. Okay, I'm going to sign out again and log back in. Let's check questions, if there are any. We are good. Okay, let me take a quick stretch break. Water break. Okay. I'm back. Let's continue. 292. Almost at 3. Well, kinda. You got a ways to go. Let's stick to it. Let's keep with it. All right. Reflecting a point across both coordinate axes. Reflect A across the x-axis, then reflect the result across the y-axis. Okay. So first we're going across the x-axis, and then the y. So if we reflect it across the x-axis, we go, it's 5 up, so we go 5 down. And then across the y, this result across the y, so we're 3 to the left of the y, so then we reflect across the y. Boom. But we don't want this point. We only want the final point. So that's all we do. Reflect across both. So we do across the x, then across the y. Well, we can't really reflect it across the x because it's on the x, so it just stays there. And then across the y we go, it's at -7, we jump all the way to +7. All right, last but not least, reflect across both, right? Y-axis then x-axis. The order actually doesn't matter. But across the y-axis first, here we're at 5 to the right of the y-axis. Now we go 5 to the left. And then we're 4 above the x-axis, so we go 4 below. This goes away. And we're done. All right, signed decimal multiplication. So first of all, it's important to remember the rules with negatives. You multiply a negative times a negative, it becomes a positive. So this one's going to be positive. Then you have a positive times a negative. It's like the negative dominates and infects, and we're going to get a negative. So this one's going to be negative. So in this case here, we just got to do the multiplication. 0.5 times 43 is 15, carry the 121, move the decimal over one spot. We got a positive 21.5. Here, this is by a power of 10, essentially. This is actually a little bit easier. We go once, twice, 3 times, right? So this is like 10 to the -3rd, essentially. So since we have the 1, not here, but here, 3 spots to the right of the decimal, we just move this decimal once, twice, 3 times that way. And so our answer here is -0.7852. Positive 21.5, 0.7852. Oh shoot, this is supposed to be negative. My bad. Oh! Did I mix it up? What happened? 21.5. Didn't I put a negative there? I don't know what happened. Okay, let's try it again. All right, so let's do this one more time. So we got -100 times -4.525. All right, so we got a negative times a negative, which becomes a positive. So we know this is going to be positive. And when we're multiplying by power of 10, this is pretty good because we multiply by 100, we got 2 zeros, which means we just move the decimal 2 spots to the right. So this is positive 452.5. And then this is -2.7 times 6, which equals 6 times that. This is a negative times a positive, so the answer is going to be -42, carry the 4, 12, plus 4 is 16, 1 spot over, and we got -16.2. So we got 452.5, and we got -16.2. Okay, next. Now we got 0.03 times -3. It's a positive times a negative. It's going to be negative. And then it's 3 times 0.03, which is 0.09. I can kind of do that mentally. And then again, we got this nice power of 10, essentially. So it's 0.1. So really what we're doing is we're just shifting this decimal 1 spot to the left. And since it's a negative times a negative, it's a positive. So the bottom one is 36.22 positive. So -0.09, this is 36.22. Last but not least, oh, they wanted a 0 in front. -5, so it's a negative times a positive is going to be negative, and we got multiplied by 10. That means we move the decimal 1 spot to the right, so it's -52.98. This one is -9. Negative times a negative is a positive. 9 times 0.4 is just 36, and then we move the decimal 1 spot over, so it's positive 3.6. Okay, cool. Using a table of equivalent ratios to find a missing quantity in a ratio. For parts A and B below, choose the correct description. Fill in the blanks as necessary. A certain arcade game gives players tickets. The table below shows the number of tickets a player gets for the number of points. So this one, we'd say 2 points gives you 18 tickets. So 1 point will probably give you 9 tickets. That's what we think. So we're looking for a multiplier that is consistent across. 2 times 9 is 18. So that means the same multiplier should ideally be here. 4 times 9, that is 36. 8 times 9, that is 72. So each point appears to give the same number of tickets. So since we're always going multiplying by 9, how many points would we have to get 81 tickets? Meaning, what times 9 gives me 81? It's 9. Okay, this one I'll write out a little bit more clearly. So we got 2 to 12. 5 to 25, and 7 to 35. So we're seeing amount of pounds, amount of tuna, and price. So to go from here to here, we're multiplying by 6. To go from here to here, we're not multiplying by 6, we're multiplying by 5. Here we're multiplying by 5 as well. So this is like $5 a pound. This is like $6 a pound. Therefore, the price for each pound of tuna is not always the same. Let's look at this. 3 to 9, 6 to 18, and 8 to 24. Here we're multiplying by 3. Right, that works. Here we're multiplying again by 3. And here again we're multiplying by 3. So yes, it appears to take the same amount of time to serve each customer. Therefore, 27 minutes. How many customers would that be? What times 3 equals 27? It's 9. Oops. And then we've got this number of points is here. 36 is 4. 81 is 9. So going up, we're multiplying by 3, multiplying by, oh, sorry, not by 3, by 9. Multiplying by 9, and again multiplying by 9, so I think it's consistent. Yes, it does earn the same points. Predicted number of points for spending $10. Again, this is dollars down here, $10. Follow the same paradigm. We multiply by 9, get 90 points. All right, last but not least, going from time to distance. Okay, 4 times 7, 28. 7 times 6, 9 times 6. No, does not always go the same distance. It's not a consistent multiplier. Right? Now, what about here? 3 times 8, 24. 5 times 8, yes, 40. 9 times 8, yes, 72. It is always the same. So what times 8 is going to get us to 80? That's 10. So 10 people would cost $80. Okay, identifying solutions to a one-step linear inequality. 5w is greater than or equal to 35. Identifying solutions, another way of saying isolate w. 5 is multiplying the w. Opposite of that is divide. Divide both sides by 5, and we get w is greater than or equal to 7. That means all values greater than or equal to 7 are solutions. This is not. This is greater than 7. This is greater than 7. This is not. Next. 43 is less than or equal to 34 plus x. We need to isolate x. 34 is being added to x. Like subtract 34 from both sides, and we get x is greater than or equal to 43 minus 34 is 9. So x is all values greater than or equal to 9. This is greater than 9. This is greater than 9. This is not greater than 9. This is equal to 9, which is still good because we got the equal symbol down there. Last but not least, 9 is greater than x minus 39. Isolate x. We need to add 39 to both sides. X is less than 48. All values less than 48 are good. This is greater than it, so no good. Less than 48, yes. Less than 48, yes. Greater than 48, no. All right, Melissa bought N packs of pencils. Each pack has 12 pencils. Okay. Write an equation to represent the total number of pencils that Melissa bought. The total number of pencils equals the number of packs, right? But then where's this 12 fit in? Well, if she buys one pack, she's got 12 pencils because each pack has 12, right? Well, what happens if she buys two packs? Sorry, she's going to have 24 pencils, right? 2 packs, each one 12, 24. 3 packs, 36. What am I doing? I'm taking the number of packs and I'm multiplying it by 12 to get to here. Therefore, the number of pencils total equals the number of packs N times the number of pencils per pack, 12. So P equals N times 8 times, how do they want us to write this? Oh, I think they just want us to say 12N. Yeah. That is 12 times N or N times 12, same thing. A pound of chocolate costs $6. Yoko buys P pounds. Write an equation to represent the total cost C that Yoko pays. So again, the total cost equals the number of pounds, right, times 6, because 1 pound costs $6. We can agree on that. 2 pounds cost $12. 3 pounds cost 18. We're always multiplying the number of pounds by the price per pound. C equals 6P. All right, next, Keisha plans to watch 2 movies each month. Write an equation to represent the total number of movies N that she will watch in N months. Well, she watches movies for 1 month. She's watching 2 movies. 2 months, that's 4 movies. 3 months, that's 6 movies. It's always 2 times the number of months that she is watching these movies for. So N equals 2M. 2 times M. All right, let's keep going. For each table, determine whether it shows that X and Y are proportional. Okay. So if they're proportional, what we need to know is there needs to be that common multiplier to get from each X value to the Y value. So let's look at this first one here. To go from 9 to 54, well, we multiply by 6, so that's cool. Are we doing the same thing here? Yes. Are we doing the same thing here? Yes. Therefore, it is proportional. Y is what times X? It's 6 times X. What about here? It looks like it's 2 times Y. 2, no, now it's 4 times Y. Now it's 8 times Y. This is not proportional, meaning there's not a consistent multiplier taking us from X to Y. Okay, what about this? Multiplier of 9. Multiplier of 9. 9. 9. Yes. Y is 9 times X. Looks like a multiplier of 7. 7. 7. 7. Yes. Proportional Y is 7 times X. Last but not least, 2. 4. 6. No. Not the same multiplier across. 4, 4, 4. Yes, Y is 4 times X. And multiply each of these X's by 4 and we get the Y's. Okay. Finding outputs and rate of increase given the graph of a line that models a real-world situation. After crossing a bridge, Boris drives at a constant speed. The graph below shows the distance in miles versus the time since Boris crossed the bridge in hours. Okay. So we go 1 hour, we go 45 miles. We've gone 45 miles. 2 hours, we've gone 90 miles. 3 hours, we've gone 135 miles. Okay. Cool. What is the distance traveled at 0 hours? Well, it's right here. At 0 hours, we've gone 0 distance, 0 miles. What is the distance traveled at 1 hour? At 1 hour, we've gone 45 miles. How much does the distance increase for each hour since Boris crossed the bridge? 45, another hour we go to 90, another hour we go to 135. So each hour we're going up by 45 miles. Are the amounts given in parts B and C equal? Why or why not? Yes, because the line passes through 0, 0. Yes, because the line does not cross through 0, 0. It does cross through 0, 0. This is 0, 0, and that's why. This is... what's it called? This is essentially like a proportional relationship where we're going through 0, 0, and anytime we want to know where we're at, it's just a multiplier, right? It's a multiplier of 45 times the number of hours driven, and that's it. Melissa makes house calls. For each, she is paid a base amount and makes additional money for each hour she works. What does Melissa's pay for a house call if she doesn't work any hours? Meaning, if she's at 0 hours, what does she make? $45. What is her pay if she works 1 hour? Looks like 60. How much does her pay increase for each hour worked? Well, let's see. From 0, she's 45. 1, she's got 60. So it looks like 15. We go from 1 to 2, she's going from 60 to 75. Again, 15. Are the amounts given in parts B and C equal? No, because the line does not pass through 0, 0. Again, it's not a proportional relationship. 0, 0 would be here. It doesn't go through 0, 0. Okay. The sugar sweet company needs to transport sugar to market. The graph below shows the transporting cost in dollars versus the weight of the sugar being transported. So weight versus cost. What is the cost of transporting 0 tons? 0 tons costs, what is it on the y-axis? 500. What is the cost of transporting 1 ton? 1 ton is $2,000. How much does the cost increase for each ton transported? Well, we're going from 1 to 2. It looks like it goes up by 1,500, right? 500 to 2,000 is 1,500. 1,500. So that difference is 1,500. Again, these two values are not equal. Why? Because the line doesn't pass through 0, 0. Okay. Introduction to the power of a power rule with exponents. So what is this rule? 5 to the 4th to the 4th. Now, when we have exponents to another exponent, it's actually pretty straightforward. To simplify, we just multiply these exponents. We don't add, we multiply. So this becomes 5 to the 16th, and that's it. 6 to the 3rd to the 5th. 5 times 3 is 6 to the 15th. Last but not least, 3 to the 8 to the 4th, multiply 4 and 8, we get 3 to the 24th. Oh, 32. Oops. 4 times 8 is 32. Made a mistake. Let's see if I can do that again. Four to the 7 to the 3rd. Multiply those and we get 4 to the 21st. Oops. The quotient rule of exponents. The quotient rule is as follows. When we have the same base on the top and bottom, exponent, exponent, to simplify, it's the difference of these two exponents, which is a squared. If you want to see why, a to the 6 is really a times a times a, you know, it's 6 times out, over a to the 4th is a times a times a times a. And then just like when we do fraction multiplication, we can cross off the common ones on the top and bottom. Guess what? We have a times a left over, which is a squared. Next, we have y squared over y to the 7th. Subtract down. This is y to the 2 minus 7, which is y to the negative 5th. Oops, not 7. Y to the negative 5. Oh, we want without negative exponents, sorry. So in this case, instead of writing it this way, y squared over y to the 7, we can still subtract, but in this case, we're subtracting up. So the larger one is here, so it's we just keep it in the bottom now, since this is the dominant one. So we do 7 minus 2, which is 1 over y to the 5th. And coincidentally, this is the same as y to the negative 5th, but they want it this way, so that's fine. X over x to the 3rd. Remember, this is not just x, this is x to the 1st. Same thing, we're subtracting, but since the larger one's in the denominator, we do it, put it down here, keep a 1 on top, which equals 1 over x squared. Okay, let's keep going. Rotating a point and its given coordinates. The figure below has a point marked with a large dot. First, rotate the figure 180 degrees counterclockwise. Okay, so 180 is like this, and that is 180 degrees. See, all the way around, or halfway around. And then give the coordinates on the marked point in the original and the final. So that original is -1, +3. The new one is +1 on the x, -3 on the y. So +1, -3. And what's interesting is you see 180-degree rotation, the signs of each coordinate just flips. Okay, 270 degrees. So here's 90, here's 180, and here's 270. 360 would be all the way around. That original coordinate looks like 7, 2, 7, 2, and this new coordinate is 2, -7. Oh, clockwise. Whoops, I made a mistake. That's important. So clockwise is the other direction. So it's 90, 180, and then 270. My mistake. Original's the same. The new one is -2, +7. -2, +7. Got to read those instructions carefully. Counterclockwise by 90 degrees. So that is counterclockwise. That's opposite the direction of a clock goes. Clock goes like this, right? And so the original point is here. Wait, where was the original point again? Oh yeah, that was the original point in gray. So the original point is -4, -1. The new point is 1, -4, 1. Figure below has a point marked with a large dot right here. First, rotate the figure 180 clockwise. Clockwise, we're going in the direction of a clock. Boom. And then give the coordinate of the marked in the original and the final. Original looks like 2, -3. 2, -3. The final is -2, +3. Okay, cool. All right, let's compare. How do we compare fractions? Okay, by finding a common denominator. So we got 4/5 and 3/4. What's our common denominator? Well, it's our least common multiple. In this case, it's going to be 20 for 5 and 4. Okay, so how do we get 4/5 to have a denominator of 20? We multiply the top and bottom by 4, and we get 16/20. What about 3/4? We multiply the top and bottom by 5, and we get 15/20. So this becomes 16/20, and this becomes 15/20. Once we have common denominators, we can quickly see which is the bigger fraction. It's the one with the larger numerator, which is 16/20, which equates to 4/5. Therefore, 4/5 is greater than 3/4. Okay, next. We're comparing 8/9 and 5/6. So what's the least common denominator here? It's actually going to be 18. So I'm going to multiply the top and bottom by 2, and I'm going to get 16/18. For 5/6, I'm going to multiply the top and bottom by 3, and we're going to get 15/18. Therefore, this one is bigger, which corresponds to 8/9. Therefore, 8/9 is larger. All right, last but not least, 1/3 and 3/8. The least common denominator is 24, so 3, 8, and 8. 3 and 3. 8/24. 9/24. Which one's bigger? This guy. So we've got 8/24. 9/24. Therefore, 3/8 is bigger. Boom. Converting a fraction to a percentage in a real-world situation. All right, hold on. I'm going to stretch again. We're getting close to the 3-hour mark, and oof, I'm getting tired. Stretch break. Okay. Okay, let's keep going. All right. I am going to log out. Make sure this keeps running smoothly. Log back in. Okay. Let's just see if we got any more comments. No. let's keep it going. 48%. My goal was 50%. We're getting there. I have to do another 12 topics. Yeah, let's see what we can do here. Okay, mean of a data set. Mean, how do we calculate the mean? It's also the average. We add up all these numbers and divide by the number of numbers we have, which in this case is 7. So I'm going to show you a cool way to use the calculator. You can kind of highlight all the numbers. It puts them in for you. Oops. Then we're just going to add them up. Right? And then we get 89, and we take that 89 and we divide it by 7, and that's it. So we add these guys up, divide it by the number there are, and we get this value. And then it says round it to the nearest tenth, which is right here. And since this number is less than 5, we keep it at 12.7. Next, we're going to add these up again. All right, and then we take that and we divide it by the number of students, which is 8. Whoops, 8. And we get 9.625 round to the nearest tenth, which is again here. That number is less than 5, so we keep it at 9.6. Last but not least, I'm just going to do this mentally. 7 plus 16 is 23, 28, 38, 39, and then 45. 45 divided by 5 is 9. Just make sure. So we get 9 pounds. There's no reason to round it. Let me do that right. 17, 21, 21, 31, 37. Oh, it's 44. No, I did that wrong. Let's do it this way with the calculator. It goes off by 1. Oops, I put a 9 in front. Okay, so we've got plus equals, oh, it is 45. So it is 5. Ah, what? It's weird. I just added them up, right? Okay, let's try it one more time. Oh, sorry. It's supposed to be 9 divided by 5. Divided by 5, not divided by 9. Okay, whoops. And then last but not least, $13, $17, $9, $11, $20, $5, $4. Okay. Which equals this divided by 7. Which equals 11.28. Round to the nearest tenth. Since that's bigger than 5, we round this up to 11.3. There we go. Okay, using distributive and combining. What is this? Oh. Using distribution and combining like terms to simplify. All right. Negative v plus 3 minus 2v. So what do we do? First thing I like to say when we're looking at simplification of expressions like this is tackle this parentheses. We want to get rid of these parentheses. So how do we do that? Whatever's outside the parentheses, we have to distribute. So this is not just a minus, this is a -1. This -1 has to distribute and multiply each of these values since these guys don't combine. -1 times v is -v. -1 times 3 is -3. And then minus 2v. This minus 2v is actually a -2v, right? So we want to think about it as a -2v. And then we combine the like terms. These both have v's. A -1v plus a -2v. Same team, so they combine to a -3v. And these are not like terms, so they stay separate. And that's your final answer. Next one, we have 2 times 3x plus 1 minus 5. So first let's apply the distributive property again. 2 times 3x is 6x. 2 times 1 is 2 minus 5. Now these are my like terms because they're the two numbers by themselves. So then it's 6x, and then 2 minus 5 is negative 3. So it's 6x minus 3. Next. Finally, we have negative v plus 2 plus 3 times 3v plus 5. Again, let's deal with the parentheses first. Distribute that negative 1, and that becomes negative v minus 2. Plus, this distributes here, becomes 3 times 3 is 9v, plus 3 times 5 is 15. These guys combine, 9v plus negative v is 8v. These guys combine, and negative 2 plus 15 is positive 13. 8v plus 13. All right, solve for x. Again, when we say solve for x, that just means isolate x. So we need to get x by itself. Since m is on the same side, we need to see what's m doing to x. It's multiplying. What's the opposite of multiplying? Divide. So I'm going to divide both sides by m, and we get x equals 2 over m. We have, w equals a over 4. Solve for a. So the a we need to get rid of. A is dividing the 4. Opposite of that, we multiply both sides by 4 to get rid of this. And we isolated a. A equals 4w. Or 4 capital W. Last, we have a equals 8h. We're solving for h. The 8 is multiplying the h, so I'm going to divide both sides by 8. And we get h equals a over 8. Okay, let's keep going. Next question. Given one pair of supplementary angles and one pair of vertical angles shown in the figure below. Okay, what are supplementary angles? Supplementary angles are angles that add up to 180 degrees. So any angles that are kind of on a straight line will be add up to 180. So in this case, we can see that we got this angle plus this angle, since they're along a straight line, will be supplementary. So angle 5 and angle 6 are supplementary. They add up to 180. Vertical angles are kind of like opposite each other. So if we have crosshairs, we could see that 6 and 1 are vertical. We can also see that 2 and 5 are vertical, 3 and 8 are vertical, 4 and 7. So there's so many options for this. I'm going to just go with 6 and 1 as vertical angles. Okay, next, same thing, vertical angles. Let's go with 1 and 3. They're opposite each other like that, across from the way. And then supplementary angles, let's go with 3 and 4. They're on the same side. They kind of add up to a straight line, so they're supplementary. Last but not least, we've got vertical angles as 1 and 4. Let's do down here 5 and 8. And we've got supplementary as 5 and 7 along that straight line. 5 and 7. Again, supplementary add up to 180. Finding the coordinates of a point reflected across an axis. Okay. Give the coordinates of the point obtained from each reflection. Reflect this across the y-axis. So here's the deal. What's happening is if we have this, I'll draw this one out, but then I'm not going to draw the rest out. We have this at, let's say this is -4 and this is -5, right? Something like this. If we reflect it across the y-axis, we jump it over here. And what's going to happen? It's going to stay at -5, but it's going to jump to +4. So what's the shortcut? The shortcut is when we reflect across the y, we flip the x value and keep the y value. What about this reflected across the x-axis? Well, we're down here 5 below. We're going to jump it up top and be 5 above. So this is going to be -4, +5. So what happens when we reflect across the x-axis? We just flip the y value. So it's like across the x, we flip the y. Across the y, we flip the x. So this is -4. The x stays the same. This becomes +5. Reflect across the x-axis, we flip the y. But wait a minute, it's 0. What's -0? There's no such thing as just 0, so that stays the same. What about this? Across the y-axis, we flip the x. Okay, last but not least, flip it across the y. I'm going to change the x to -9, 7. This one goes to 9, -7. All right, area between two rectangles. A rectangular region is removed from another rectangular region to create the shaded region shown below. Find the area of the shaded region. Well, first of all, let's calculate the area of this entire rectangle, okay, which is 9 times 16, which is 144. And then we need to subtract this rectangle away. They literally cut this rectangle out. This little rectangle is 6 by 8, 6 times 8, which is 48. And then it just becomes a subtraction problem, right? 14 minus 8 is 6. 13 minus 4 is 9. So the remaining area is 96 millimeters squared. Okay, same deal here. Try to draw this as best I can. So the bigger rectangle is 7 by 15. The smaller one is 5 by 13. So the bigger one is 7 times 15, which is 105. The smaller one is 5 times 13, 60, 50, 65. And now we subtract. We get 0, and we get 4. So it's 40. Okay, last but not least, a rectangular region is removed from another rectangular region, same deal. So the bigger rectangle is 8 by 17, which is 80 plus 35, which is 115. No, sorry. 80 plus 56 is 136. And then this little guy in here is 3 by 8, so minus 24. So the remaining is 112 yards squared. Scientist wants to find the average weight of fish living in a large pond. So she will use the weights of 52 fish from the pond to find the average weight. Answer the questions below. Which units could be used for the unit of measurement? Check all that apply. Well, measurement for weight could be ounces. Could it be seconds? Could it be hours? Could it be minutes? Could it be also pounds? Right? Because we're talking about weight, so ounces or pounds. Which of the procedures below would be the best way to find the average weight? Okay. Randomly pick 52 fish and weigh each of them. This is probably pretty good. It's very important that it's random. This is the whole idea, is we don't want to have any biases. So it's important that we say randomly picked. Randomly pick 52 from the entire pond and estimate their weights. That's not as good as weighing them. Weighing them is better because estimating, you're kind of guessing. Pick 52 fish from a shallow pond and estimate. No, because now you're picking. Now you're introducing a bias. You're really skewing the data towards fish that like to swim in the shallow end. And then pick 52 and then weigh each of them. This is better than estimating, but this is the best. Randomly pick and then weigh each one. So it's the best method. Next, Kevin wants to find the average height, so he will use a sample of students from 10th grade. So if we want height, we need a measurement of length, which is centimeters, inches, or feet. Which of the following procedures would be the best way to find the average height? Ask for 44 volunteers to state their own heights. It's okay, but that introduces their own biases. Maybe some think they're taller than they are or shorter than they are. Measure the height of 3 volunteers. That's okay. It's a small sample. Randomly pick 44 students from 10th grade and measure their heights. That sounds good. Random. We're picking a bunch. And then we're actually measuring. Randomly pick 3 students and have them, again, state their own heights. Small sample size, and then you're having them state it themselves. Not good. So that's our best one. Last but not least, which units could be used for the unit measurement here? Ali wants to find the average time it takes students to run a lap around a track. So we want time now. How much time does it take? It could be in hours or seconds. So measure the time of 32 volunteers, maybe. Ask for 32 volunteers to run and have them state their own times. We don't want them to state their own times. Randomly, that sounds good. Pick 32 students and have them state their own times, but better yet, randomly pick and measure their times. There's no biases from their own desires to want their times to be faster or slower or anything. All right, order of operations with PEMDAS. Let's do it. 6 minus -3 times -6. What do we do first here? We're going to do a little multiplication first. So we do -3 times -6, which is 18. Positive, the negatives cancel each other out. And then we do 6 minus 18, which is -12. Right? I'm doing the multiplication before that stuff. Now we have 3 times -3 minus -9. First we do multiplication. Here's multiplication. No parentheses, no exponents. So this becomes -9 minus -9. Now we combine these guys, but a minus and negative turns to a positive, so it's -9 plus +9 is 0. Last but not least, we have 4 minus 8 divided by -4. Division, no parentheses, no exponents, no multiplication, but we have division, so this happens first. 8 divided by -4, or -8, doesn't matter. We can actually tag this with a negative. We'll get the same either way. So -8 divided by -4 is +2. And then we do 4 plus 2, which is the addition, which is just 6. Finding benchmark fractions and percentages for a figure. The strip below is divided into 4 equal parts. Fill in, all right, so let's see. The number line below is divided into 5 equal parts. Fill in the missing fractions and percentages. Well, let's choose one first. Let's choose the fractions first. This is 4 out of 5, which makes sense. 1, 2, 3, 4 parts out of 5. How far is this? This is 1, 2 out of 5. So this is 2 out of 5. And this is 1 out of 5. Now let's look at the trend and the percentages. So this accounts for 100 split up into 1, 2, 3, 4, 5 pieces. So that means 100 split up by 5 or divided by 5 is 20. So each one of these notches up by 20%, 40, and 60. Okay, we divided us up into 4 equal parts. 1, 2, 3, and 4. So this is 1 out of 4. This is 2 out of 4. And this is 3 out of 4. And what about these percentages? Well, look at this. It's 100 divided up by 4, which is 25. So each one of these is 25. Then goes up by 25, which is 50, 75, and 100. This is split up into 5 pieces. 1, 2, 3, 4, 5. So we know that this is 1 out of 5, 2 out of 5, 3 out of 5, and 4 out of 5. And what about this? We've got split up 100 split up into 5 pieces, which each one of that is 20%. Notice how 20% is equivalent to 1/5. This is going to be 40%, and there we go. All right, finding a percentage of a whole number. All right, 3% of 21. How do we do this? Remember, 3% of is multiplication. So we're doing 3% times 21, but before we do the multiplication, we have to convert this to the decimal equivalent. We do that by moving the decimal over once, twice. We get 0.03. Now we get 0.03 times 21. That's 3. 3 times 2 is 6. We don't need to do this 0 multiplication because it ends up being 0, 0. And then we add them, 3, 6. But where do we put the decimal spot? Since there's 2 numbers to the right of the decimal, we go 2 to the left like that, and we have 0.63. Oh wait, 0. 65% of 43. So again, convert this to the decimal equivalent, which is 0.65. Multiply that by 43. 5 times 3 is 15. Carry the 1, 20, 21, 0. 6 times 3 is 18. Carry the 1, 24 plus 1 is 25. Add it. 5, 9, 7, 2. With 2 spots to the right, so we go 2 spots to the left. We get 27.95. Last but not least, 76% of 35, which means we do 0.76 times 35. 0.76 times 35. 6 times 5 is 30. Carry the 3. 6 times 3 is 18. Plus 3 is 21. 0. 7 times 5 is 35. Carry the 3. 7 times 3 is 21. Plus 3 is 24. We have 0, 6, 6, and 2. And the decimal goes once, twice, because we have 2 spots to the right. So it's 26.6. I could say 0, but I'm just going to say 26.6. And that's going to be right. All right, let me just see where we're at percentage-wise. 50%. Oh, they rounded up. That's close enough. I'm going to take a break because I am exhausted, and that was a long session. So I've been live streaming now for 3 hours and 20 minutes, and that was intense. But I'm feeling good. These topics are being edited down and uploaded as fast as I can go up to YouTube. So we're halfway there in terms of solving the problems. Not halfway there yet in terms of the uploads, but I'm going to get there some point by this weekend. And pretty soon we'll have the entire Pre-Algebra ALEKS curriculum online for you guys to peruse at your leisure. Thank you guys for joining. I hope you enjoyed this. If you did like this, please click like down below. And if you want to see more of this stuff, definitely subscribe to the channel. We've got a lot more coming your way every week, every day, as much content as I can muster to create. Thank you guys so much, and have a great rest of your day. Take it easy.